He drifts along a quiet shore of stars, where light thins and the deep geometry of the universe hums beneath awareness. The name sounds fierce, yet the presence is tender. A black hole is not a roaring mouth and not a cosmic storm. It is a patient curve in space-time that asks nothing more than surrender to the simplest path. Around it, the night looks like velvet held taut. The fabric is not ripped, it is curved. Gravity is not a shout, it is a hand on the shoulder that guides, steady and unhurried. Seen from afar, the region looks empty. Felt from within, it is pure order, wrapped in silence. In every tranquil image of a moonlit lake, there is a lesson about reflection and stillness. The lake does not force the sky to kneel, it simply offers a flatness so complete that stars learn how to sit. A black hole behaves with similar courtesy. It does not claw, it smooths. It invites motion to follow geodesics, the straightest lines possible within a curved world. An apple falls in the orchard, a planet orbits a sun, and matter around this darkness follows the same logic. The difference is only in degree. Calm remains the rule. Even the word horizon suggests dawn and sea mist, a boundary defined by light and not by violence. There is a practical serenity at play. In the domain of a supermassive black hole, tidal forces can be gentle across a human body. Crossing the threshold would not announce itself with tearing or crushing, not for the truly large ones that sit in galactic hearts. The passage would be uneventful, the way a boat slips through a reflection of the moon. Nature keeps her drama at the scale of mathematics. The curvature intensifies, the coordinates rearrange their duties, and yet a traveler who has already committed to the inward path would notice no abrupt alarm. The calm at the edge is not a trick. It is the truth of how space-time handles speed and light. Time itself begins to loosen into softness near that boundary. Distant clocks continue their lively tick, but the clock carried by the falling traveler stretches each second into a wider, quieter room. The outside observer will swear that motion slows to a halt. The traveler will swear that minutes keep their rhythm. Both are correct within their frames. This is not confusion. It is the universe taking two perspectives and granting each the dignity of its own cadence. The result is oddly comforting. The cosmos is large enough to hold more than one honest tempo. Light changes its color as it tries to leave. Photons lift away with resolve, only to find their energy diluted by the climb. The glow reddens, then deepens toward invisibility. Nothing explodes, nothing cracks. A hard beam becomes a soft ember, then a warmth imagined rather than measured. The darkness that follows is not absence. It is information stored beyond reach, folded into a geometry that refuses to fray. The eye calls it night. The equations call it a solution. Both words are accurate in their own domains. The surface that is not a surface, the horizon that no one can touch, sits like a perfect pause. It is a contour in the map of causality. On one side, light can visit the open universe. On the other side, light can only continue inward, always inward, along routes that are simple in their inevitability. No seam marks the transition. No membrane needs to be painted across the sky. The quiet here is familiar, like the open sea at dawn when the wind has not yet chosen a direction. Perhaps that is why the first images of a black hole's silhouette felt less like discovery and more like recognition. The mind had already learned the shape from lakes, from pupils, from caves and wells. There is comfort in simplicity, and black holes are among the simplest objects that the cosmos permits. A handful of numbers would describe one to a high degree of completeness. Mass measures the weight of the curve. Spin remembers how the original star twisted as it died. Charge could, in principle, add a final parameter, though the universe seldom keeps it. The rest is trimmed away by the environment, shaved off by radiation and friction, or swallowed in the gentle insistence of the horizon. What remains is a portrait without clutter, a kind of cosmic minimalism. The complicated chaos of formation ends in a clear, compact identity that does not age in the haphazard way of ordinary things. Even the paths that light can take near this quiet center find a graceful choreography. There exists a distance where photons can circle and circle, flirting with escape, always turning back, like birds playing at the edge of a thermal. The looping is not frantic, it is precise and calculable. In such patterns, the universe hints that beauty and predictability are partners rather than rivals. Astronomers measure these motions and translate them into frequencies. Out in the cold, detectors listen to the music of gravity. And in that music, there is no scream. There is only a low, resonant hum. Consider the scale that makes terror dissolve. A black hole at the heart of a galaxy can weigh millions of suns. Its horizon stretches wider than a solar system, which means the gradient from head to heel for a person would be forgiving. Tides become lullabies at such distances. Only the patient inward journey changes the story, and even that journey would be marked by smooth acceleration rather than jagged trauma. The drama in popular tales belongs more to imagination than to physics. The reality is disciplined. The curvature does what curvature does, and the traveler follows the line that asks for the least effort. What seems most soothing is the idea that the darkest region in the sky obeys rules with exquisite loyalty. The same principles that govern apples and orbits hold firm, simply extended into a regime where light is as much a participant as matter. There are no special exceptions here, no tempers, no rebellions. If the universe were a library of laws, the black hole would be a reading room where silence is respected and every step leaves the arrangements tidier than before. The quiet is not indifference. It is fidelity to form. Human fear often comes from not knowing where a path goes. The black hole removes that uncertainty for anything that crosses the boundary. The future is set in a direction that points inward, which is not the same as meaning or purpose, yet it has the emotional flavor of certainty. Outside, the cosmos is full of scattering and collisions, of choices and chance. Here, the route becomes clean. There is a peace in that, unsettling only if one insists on control. The universe offers a place where surrender is not defeat, merely agreement with geometry. In the larger picture, the presence of these quiet wells helps galaxies remember their shape. Stars swing in wide loops, gas spirals with patient release of heat, jets rise where magnetic lines find order. Nothing about this seems frantic when viewed at proper scale. With enough distance, every river looks slow. With enough time, every orbit becomes a poem. The black hole does not write the poem, but it sets the meter. Its gravity supplies the gentle downbeat that keeps the measures even. He stands on a hill under a clear night and senses this. The mind is a small thing, yet it knows how to breathe with the sky. The word for that is trust. Trust that the quietest places in the universe are also the most exact. Trust that darkness is not always chaos, that it can be a careful accounting of what continues and what cannot return. He looks up and feels less hurried. Somewhere in that field of stars, space curves into a patient bowl. It is not a warning, it is an invitation to listen. He hears the story begin in a small English study, where ink dries slowly and winter presses against the panes. John Mitchell writes a letter in 1783 and imagines a star so heavy and so compact that light itself would need to climb a terrible hill to escape. If the hill were steep enough, no beam could crest it. He calls it a dark star, not from dread, but from geometry. The thought arrives without fanfare. It is a calm act of arithmetic applied to Newton's gravity and the finite speed of light, a gentle alignment of two truths. Others will hesitate at the idea, yet the seed is planted with quiet confidence. Joseph Louis Lagrange and Pierre-Simon Laplace consider similar calculations, testing how fast light must move to break free from a deep gravitational well. Their notebooks carry an understated audacity, as if they know the universe will someday reward patience. No one possesses the framework to say what such an object would truly be. The picture is foggy. The principle is clear. A shadow can be cast without smoke or fire when gravity gathers matter past a certain threshold. The early musings rest like smooth stones beside a river, each shaping the flow in small ways. The river bends abruptly with Albert Einstein. In 1915, he presents equations that turn gravity into the architecture of spacetime. Mass tells space how to curve. Curvature guides mass and light along the straightest possible lines within that curvature. The union is elegant, not loud. A year later, Karl Schwarzschild, serving at the front in a world at war, sends a solution from the trenches. It describes a spherical mass with a radius so compact that light cannot escape if it attempts to climb from inside that radius. The mathematics does not shake or flare. It sits with the serenity of a perfect circle. a horizon emerges from symbols as naturally as dawn from night. For a time, many doubt that nature would ever build such a thing. Arthur Eddington, who confirmed starlight bending around the sun, initially approaches the apparent singularities with skepticism. The equations suggest a boundary that looks like a flaw if one uses the wrong coordinates, a superficial kink that can be smoothed by clearer variables. The realization grows that the boundary is not a tear, it is a feature, a place where causality tilts. The learning arrives in increments, each paper another small exhale, until the horizon acquires the status of a real geometric stage, not a mathematical mirage. Decades slide by, and then the star itself steps into the narrative. In 1939, J. Robert Oppenheimer and Hartland Snyder follow the fate of a massive star once its nuclear furnace fails. Without pressure from fusion, gravity collects the core. The collapse accelerates, and the surface approaches a point where outgoing light can no longer reach distant observers. It is not a catastrophe in mood. It is an obedience to the simplest available future. Their calculation gives a path for nature to build the very object that had lived mostly in thought. The idea leaves the desk and seeks the sky. The sky answers through radio dishes and optical plates. Astronomers notice quasars in the 1,960 seconds, distant beacons outshining entire galaxies with energy too focused and too profuse to be explained by ordinary stars. The engines seem compact and heavy, exactly the kind of gravitational furnaces that could arise when matter swirls into deep wells. Around the same time, in laboratories and lecture halls, John Wheeler searches for a name that captures both simplicity and finality. He begins to say, black hole. The phrase lands without ornament. It does not dramatize, it clarifies. The public hears it, and the picture locks into place. Evidence tightens with the discovery of Cygnus X1 as a powerful X-ray source, paired with a blue supergiant. The compact companion betrays a mass too large for a white dwarf or a typical neutron star. The inference is steady and conservative. What remains after eliminating the usual categories is a black hole. The method resembles a sculptor's patience, chipping away what the object cannot be until the only shape left is the thing itself. Observations refine masses and spins. The story becomes one of measurement, not proclamation. Supermassive versions claim the centers of galaxies, including the quiet one that anchors the Milky Way. Stellar motions near that central radio source trace orbit so tight that only a compact mass of millions of suns can explain them. The inference feels like watching planets confirm a hidden sun, except the sun here is not a shining sphere but a region whose gravity dictates the dance without a visible face. Each measured ellipse closes the case with restrained certainty. Telescopes convert silence into coordinates that point to a concentrated darkness. The theoretical structure around these objects grows in parallel. Roy Kerr finds a solution for a rotating mass in 1963. The horizon now possesses a frame-dragging effect that twists space around it, a kind of slow whirl embedded within the geometry. The result is richer, yet still governed by a few clean parameters. Physicists learn how to read the exterior fields and infer the interior's simplicity. The phrase, no hair, becomes shorthand for the way complexity falls away as the object settles into its minimal identity. The lesson is austere and calming. Nature reduces the vocabulary to mass, spin, and perhaps charge, and lets the rest fade into equilibrium. The image in popular imagination might suggest chaos at the brink, but the record shows an accumulation of calm verifications. Binary systems with periodic signatures, broadened spectral lines that hint at swift inner orbits, jets that rise from magnetized disks and point with remarkable stability. Each clue arrives through careful reduction of noise. Instruments improve, analysts subtract backgrounds. Signals are teased out with the patience of someone listening for a heartbeat beneath a quiet chest. The pulses, flares, and shadows align with expectations from curved space-time. This history does not rush. It breathes at the pace of methods becoming more precise. A thought experiment from the 18th century becomes a set of exact equations in the early 20th, then a plausible pathway for stellar death, then a roster of convincing observations across the electromagnetic spectrum. The path travels from ink and chalk to antennas and interferometers, while keeping the same core melody: gravity bends. Light follows. Mass compacts. Horizons form. The tone remains one of understatement, the way a craftsman describes a finished chair by running a hand along the grain. Names gather along the way. Mickel for the audacity of the first draft, Einstein for the geometry, Schwarzschild for the exactness under fire, Oppenheimer and Snyder for the star's final obedience, Wheeler for a word that people can carry like a stone in the pocket, Kerr for the spinning refinement. The cast does not compete. Each contributes an element that makes the picture more natural. The timeline reads like a series of small lanterns placed along a path through a deep garden. None blazes. Together they show the way. He imagines an archive room where these pages rest side by side. The room is dim and cool. In the quiet, the equations feel like well-made tools arranged on a bench. There is a sense that all this could have been otherwise. The universe could have hidden its deep wells behind chaotic signals and unreachable scales. Instead, it offered signs that patient minds could read with instruments built by patient hands. Discovery became a practice of attention and repetition. What was feared as monstrous resolved into a set of testable claims that fit inside a few lines of mathematics. The arc from conjecture to confirmation brings with it a particular peace. When a mystery accommodates measurement, it ceases to haunt. The object does not become trivial, it becomes intimate. A star's quiet collapse is not a melodrama. It is the universe tidying its heavy remnants into a form that keeps the books balanced. The ledgers of energy and momentum close neatly. Light acknowledges the limit. Matter accepts the curve. The result is neither thrill nor terror. It is order at the edge of darkness, drafted by minds that learn to listen for soft signals and to trust that the sky prefers coherence. He studies a boundary that is not a line on any map, yet rules the traffic of light with perfect grace. It is called an event horizon, a surface defined not by substance but by the fate of signals. Nothing carried by light can climb from beneath it to the wider universe. The name suggests a sunrise, and that is fitting because horizons speak in the language of visibility. Here the horizon is not a distance on the ocean, it is a contour in causality. The rules are not written in ink. They live within the tilt of light cones and the geometry that decides what can be told and to whom. Approach this quiet border and strange courtesies appear. Time does not break, space does not rip. A freely falling traveller feels no snag. The horizon has no texture to the touch. Yet for distant watchers, the drama takes the form of patience stretched to infinity. Signals from the traveller grow slower, redder, dimmer. The final approach is never seen to complete, only to linger. The surface performs a kind of vanishing act that is also an accounting. Energy budgets remain exact, frequencies soften by predictable amounts, and the story closes with a glow that thins like evening light. The mathematics behind this calm is in the structure of light cones. At every event in space-time, a cone marks the possible future directions for light and anything slower than light. Far from strong gravity, the cones point outward like flowers in sunlight. Near the compact mass, the cones lean inward. At the horizon, they tip so far that the future of any particle inside points only deeper. A map with ordinary coordinates can make this look like a singularity, but that appearance is a costume. With kinder coordinates, the path flows through the surface without a seam. The lesson is that geometry does not panic. It rearranges the angles and continues. There is a delicate distinction between the photon orbit and the horizon. Photons can circle at a particular distance that lies outside the true one-way border. That orbit is unstable, like a coin balanced on its edge, yet it adds a ring to the portrait. Light that grazes this region can loop once or twice, drawing out echoes of the background as a lens that has learned patience. None of these loops violate the rule that the horizon itself is quiet and final. The orbit is play, the boundary is fate, the surface is null in the language of relativity. That means the horizon is traced by paths of light itself. It is a sleeve sewn from photons that can neither depart outward nor sink inward once they ride its edge. This gives the boundary a peculiar serenity. It is not a barrier built of matter. It is a condition that light satisfies by existing at the limit. Such a property hints at temperature and entropy, though those notions belong to later reflections. For now, it is enough to notice that nullness grants the horizon a purity that feels like still water drawn tight by surface tension. A picture that helps is the membrane view, a practical fiction that treats the horizon as a thin conducting sheet. In this view, infalling charges induce currents, magnetic lines cling, and heat can be assigned to the surface in a way that respects exterior measurements. The fiction is not a mistake. It is an instrument that lets calculations remain outside while pretending that the edge has physical traits. Observers who never cross can use it to turn riddles into sums. The surface then acquires a viscosity and a resistance that whisper of deeper thermodynamic truths. Another picture leans on how areas behave. The surface area of the horizon never decreases during classical processes. It can grow when matter falls in, and it can stay the same when nothing is added, but it does not shrink. This is a law with the softness of a lullaby. It speaks of irreversibility without bluster. Even collisions that shake the cosmos with waves of gravity must respect this rule when the dust settles. The geometry keeps its promises, adding horizon to horizon until the final total exceeds the parts. Order hides in this simple direction of change. Causality at the border has a clean etiquette. Messages sent outward from inside cannot arrive. Messages from outside can cross inward and never return. The asymmetry is absolute. This is not cruelty. It is the way the paths connect. Penrose diagrams draw this with slanted lines and compactified infinities, compressing the entire life of a spacetime into a figure small enough for paper. In these sketches, the horizon appears as a diagonal boundary that separates regions by their ability to communicate. The drawing looks serene because the rules are so clear. There are quieter cousins to these horizons in everyday acceleration. An observer that accelerates forever sees a boundary behind which events can never send a signal that catches up. That boundary is called a Rindler horizon. It reveals that horizons can be born not only from gravity, but also from the way an observer moves. The analogy is not decoration. It is a thread that ties temperature, acceleration, and quantum fields into a single fabric. Though the technical details live elsewhere, the mood they create here is patience. Boundaries can be gentle lessons in perspective. Coordinate choices can paint the horizon as a frozen shell or as a flowing river. In one set, time slows near the edge until it seems to stop. In another, space itself streams inward at the speed of light past a stationary marker while the traveler floats as if on a current. These are not contradictions. They are portraits from different angles, like sketches of the same vase under different lamps. The physics beneath them stays loyal. Objects cross the edge in finite proper time. Distant observers never see that crossing complete. Both statements live comfortably together. A distinction arises between event horizons and apparent horizons. The event horizon knows about the entire future of the spacetime, since it is defined by which paths never reach infinity. The apparent horizon is local, changing with the moment, marking where outgoing light rays are momentarily trapped. In dynamic situations, the two surfaces can differ, adjusting as matter falls or as waves pass through. The presence of both ideas keeps the boundary from becoming a cartoon. It remains a living feature that responds to context while preserving its core promise. Surface gravity gives the edge a single number that measures how hard light must try to stand still there. It is a slope in the geometry, a gentle pull that defines the feel of the boundary. This quantity links directly to a temperature in quantum treatments, yet even without invoking quanta, it offers a handle. One can say that horizons with larger mass have softer surface gravity, which in turn means more forgiveness at the edge. The universe places its fiercest curvatures on small scales and softens them as masses grow. In that gradient, there is mercy. Observatories translate these abstractions into images and timings. The silhouette cast against glowing plasma tells of a border that holds its shape over spans of hours, then days. Quasi-periodic patterns in the surrounding light map the influence of the edge on orbits just outside. When matter flares and cools, the response carries the imprint of how close it danced to the point of no return. The horizon touches the data without revealing itself, like a conductor who shapes a symphony without making a sound. He listens to the idea that this boundary is the most modest of rulers. It declares only what cannot happen. It does not dictate the choreography of the swirl outside. It does not command the interior to any particular story beyond inevitability. By confining its authority to the flow of information, it keeps the cosmos honest without becoming authoritarian. That reserve is calming. Rules that govern by omission leave room for grace. In the end, the event horizon is a promise kept by geometry. What tries to leave from within will not arrive. What approaches from without will cross in quiet and continue. There is no gate to swing, no guard to persuade, only the silent tilt of the possible. The comfort lies in that silence. A boundary that never raises its voice still orders the night. It does so with a steadiness that makes fear feel excessive and curiosity feel like a steady breath. He discovers a surprise at the heart of certainty. Gravity once felt like a patient book of rules, but the compact object draws those rules into a knot that refuses to untie. The equations say that collapse does not simply pack matter. It drives curvature toward a singular point where known descriptions cease to speak. That prediction lands like a quiet thunderclap. Physics prefers continuity. Here, the lines of explanation converge into a region where the language ends. The shock is not loud. It is the hush that follows when a trusted map runs out of ink. The scandal begins with inevitability. If a heavy star exhausts its pressure, its surface contracts, and no credible force stops the glide once a critical density is passed. The geometry guides every particle in smooth obedience. Yet the destination is a place without a finite measure of density or pressure in the classical account. Such infinities are not admired. They are warnings that the tool in hand is incomplete. The calm exterior hides a core where time and space lose their familiar duties. For a discipline raised on precision, that is an affront. The mind is asked to bow before a limit it did not expect to meet so soon. Another disturbance arises from simplicity, where complexity should have lived. The no-hair idea trims identity to mass, spin, and charge. A galaxy's worth of details in the ingredients go missing from the final product. The thermal past of the gas, the tangled magnetic stories, the composition of fallen stars, all of it dissolves into 3 numbers. This is not the ordinary loss of texture that follows equilibrium. It is a radical compression of biography into a skeletal signature. The paradox is emotional as well as technical. If nature loves to record, why does the recording fall silent at the very object that dominates the night sky's narrative? Thermodynamics adds a new chord. The horizon area refuses to shrink during classical processes. The direction of change echoes the second law that governs entropy. The formal resemblance grows too strong to ignore. One can assign an entropy to the area by simple proportion. Suddenly, an object that is pure geometry wears a thermodynamic badge. Entropy hints at microstates. Microstates hint at a hidden catalogue of possibilities. Where are those possibilities stored? How can a surface that feels like a place of no return also behave like a ledger with entries? Each step in the analogy is modest. Together they tilt the room. Quantum fields bring the softest shock of all. What seems like perfect darkness is not entirely dark. In a curved background with a horizon, the vacuum is not empty in the same way for all observers. Pairs of excitations can be separated by the boundary. One falls inward with negative energy relative to infinity. One escapes outward with a faint spectrum that looks thermal. The object glows with a temperature that is colder for larger masses and warmer for smaller ones. This glow is unimaginably gentle for giants. Yet the principle is decisive. A perfect absorber becomes a reluctant emitter. A symbol of permanence acquires a clock. The clock leads to an ending that disturbs habit. A small specimen evaporates very slowly at first, then faster as the mass falls. The timescales are large for stellar and supermassive cases, but the arithmetic is clear. Given patience beyond any human era, the object can dwindle and vanish. Where does the information go that once described the matter that fell inward? If the radiation is purely thermal, it carries no detailed memory. That possibility conflicts with the principle that quantum evolution should preserve all information. The contradiction is not melodramatic, it is surgical. 2 trusted commitments refuse to live in the same house. Another tremor lives in the horizon's kindness to different perspectives. A freely falling traveler senses nothing singular at the crossing. A hovering observer at safe remove detects heat and trembles with acceleration. In this asymmetry lies a puzzle about what counts as real. If the radiation is felt outside but not inside, How do both pictures remain true without conflict? The reconciliation is not obvious. Each frame has earned credibility, yet their coexistence tempts misunderstandings about duplication or loss. The calm geometry breeds a conceptual tension that asks for new grammar. The surface seems to count. The area serves as an entropy, yet the interior volume can grow with time in certain slicings, expanding like a roomy cavern while the outside silhouette hardly changes. If entropy measures the number of ways an object can be internally arranged, why does the boundary carry the count while the interior swells? The suggestion that information might live on the edge, rather than in the bulk, feels like a riddle told by a very patient teacher. The shock here is philosophical. Space offers volume, yet memory prefers area. Intuition yields its seat. Waves in the geometry deepen the unease. When compact objects collide, the outgoing ripples carry energy, angular momentum, and a pattern that records the properties of the final remnant. The ring-down tones are few and elegant, matching the minimal portrait. That match is reassuring, yet it also closes a door. If any hidden hair were available to encode rich stories, the spectrum would have betrayed it. The silence of extra notes is striking. Observations confirm the austerity that theory predicted. The relief of agreement arrives with a chill. They agree about how little is left to describe. Even the idea of temperature carries an insult to permanence. Temperature invites heat exchange. Heat exchange requires a notion of contact and capacity. The horizon has no substance, yet the mathematics assigns it a heat that responds to mass. The consistency of that assignment across distinct lines of reasoning builds confidence. The emotional effect is stranger. A place where nothing escapes becomes a place that radiates. A surface that is not a substance gains a temperature that no thermometer can touch directly. The world, it seems, must be told in two dialects at once. The usual safeguards of causality take on new shadows. The boundary permits entry and forbids exit for signals that obey the speed limit set by light. That is clean. Yet quantum entanglement links separated regions with correlations that do not ferry messages, but do suggest a unity that defies simple locality. If the exterior radiation is entangled with interior partners, then late emissions cannot carry new independent randomness without violating the bounds that statistical consistency demands. The bookkeeping tightens into paradox. Clean rules at the level of geometry wrestle with clean rules at the level of quantum information. Another fracture opens at the singular point predicted deep within. If that point is real, then physics does not only break its voice at an edge, it loses it entirely at the core. Deterministic stories end there. Trajectories cannot be extended. Curvature diverges beyond any scale of meaning. That outcome would be a signpost that a deeper description must take over. Yet no full replacement stands ready in the simple classroom of known theories. The gap is dignified by formal proofs that horizons and singularities arise under broad conditions. The message is severe. The path that gravity prefers leads directly into a wall of silence. The surprise is also gentle. Many of these shocks arrive as precise statements that do not scream. The horizon area obeys a monotonic law. The radiation has a temperature and a spectrum. The ring down follows frequencies predicted by clean geometry. Each item is a lullaby sung by mathematics. The tension lies in the ensemble. Put them together, and the melody starts to clash with quantum unitarity and with the hope that locality can be kept untouched. Out of quiet facts, an unease forms that keeps theorists awake. He stands at a chalkboard in the mind and writes two sentences. Geometry is faithful. Quantum information is faithful. The smooth horizon forbids drama for the traveler. The faint glow encodes a future that seems to forget. Both sentences feel morally right, as if they protect the dignity of different ideas. Held side by side, they bite. The shock is an ethical one within the culture of physics. Which loyalty should bend? The answer remains withheld. The night that once comforted now presents a riddle that feels like a mirror, asking the mind to see its own limits and to keep its voice low while it thinks. He watches time relax, as if it were a living thing, making space for each moment to breathe. Gravity, which often arrives in stories as a pull, reveals itself here as a slow hand on the metronome. Clocks near a compact mass surrender a fraction of their tempo. Clocks far away keep a quicker beat. The relation is not a mood, but a ratio, a quiet number that tells how strongly light must work to climb. A photon leaving the deep well pays with its color. A clock held near the edge pays with its pace. Both debts are honored with perfect punctuality. Two observers attempt a meeting of minds across this gradient. One hovers at a safer distance with rockets humming. The other folds into free fall, trading support for grace. They agree to exchange signals, to mark the passing of time with pulses that cannot be forged. The hovering observer receives each beat elongated. The freefall observer receives return messages shortened in rapid approach. Neither is deceived, because both can compute what should be seen once the geometry is supplied. The arithmetic becomes a lullaby of delay. Even disagreement is accounted for in the same book of rules. In this neighborhood, proper time and coordinate time become characters with distinct habits. Proper time belongs to the traveler, carried like a private wristwatch that no one else can touch. Coordinate time belongs to the global chart, the scaffolding that lets distant astronomers compare notes. Neither is superior. Each plays its role. Near the horizon, proper time hums forward for a crosser without injury, while coordinate time stretches the approach until it seems endless to the watcher who refuses to fall. The result is peaceful duplicity. Two stories remain true without quarreling, each framed by the choice of rulers and signals. Light itself learns patience. A path that would be straight in the absence of mass turns into an arc that grazes the deep. That arc comes with delay. Part of the lag is geometric, the price paid for a longer route. Part is gravitational, the time dilation that slows the clock near the mass. The combination is known in practice as a measurable tardiness of light. On grand scales, echoes of a single flare can arrive at an observatory with different delays. Because one beam skirted a heavier curve than another, time becomes a landscape. Valleys exist that are carved not from soil but from potential. Orbits contribute their own tempos to this quiet symphony. Circular paths exist only down to a firm limit. Inside that radius, circular motion cannot be sustained without thrust, and even then the cost grows steep. Just outside that line, periods shorten, precession quickens, and energy release grows efficient. Each of these facts carries a clock. Hot matter circling close to the limit modulates its light in patterns that reveal the orbital periods. The frequencies come to us as soft chimes against the continuum. They provide a direct demonstration that time near the mass is braided with curvature, not separate from it. The falling path has a paradoxical kindness. Once thrust is surrendered, a traveler can cross the distance from a modest outer marker down to the horizon in a small allotment of proper time, not with a violent snap, but with an accelerating glide. The steps compress. The beat changes. If the mass is supermassive, tidal forces remain gentle, and the passage carries no rupture of body or instrument. An onboard clock dutifully records seconds in familiar sequence. Later, if any messages sent before the crossing are recovered by the distant friend, they will show the shortening gaps between pulses predicted by the approach. The harmony between prediction and record is soothing even when the meeting cannot be completed. Stationary hovering is more strenuous in this environment than motion suggests. To remain in place near the edge requires a proper acceleration that increases without pity as the distance falls. The rockets heat. The pilot feels weight that does not come from speed but from resistance to the natural path. This stress has an internal time signature as well. A thermometer held by the hovering observer registers a peculiar temperature associated with acceleration alone. The detail belongs to a more general link between horizons and heat, yet even at the classical level, the lesson is simple. Fighting the river is costly. Floating with it is economical in the currency of proper time. Rotating spacetimes embellish the score. When the central object has spin, space itself acquires a subtle swirl. Local inertial frames are gently dragged around the axis. Clocks tied to these frames reflect the drag. A ring that attempts to counter the spin experiences different periods from a ring that goes with it. The region where no stationary hovering is possible, the ergosphere, imposes its own limit on how time can be experienced without motion. Even the direction of energy flow becomes negotiable in that zone. where clever trajectories borrow rotational energy and pay it back in the currency of altered paths. Timekeeping in this theatre reads like a tide table for a rotating sea. Redshift and blueshift bring color to this calendar. Signals emitted from deeper levels climb out diminished, their wavelengths lengthened and their frequencies softened. Signals sent inward fall in with their frequency raised. The redshift factor and its inverse form a pair that answers every question about how often a distant receiver should expect a heartbeat from a source near the brink. Long monitoring campaigns become chronicles of this transformation. As sources move radially or azimuthally, their tones glide in predictable arcs across spectrometers. Each glide is a signature of the underlying geometry, a gentle cipher resolved by steady attention. Temperature distributes itself according to gravity, with a rule that refuses to be rushed. In a static gravitational field that holds matter in equilibrium, hotter regions must be deeper if local temperatures are compared by local thermometers. When corrected for redshift, a single global condition emerges that keeps the system at peace. This principle ensures that heat does not chisel a perpetual motion machine out of a difference in rates. Near a deep well, the story is sharpened. Any notion of thermal balance must honor that clocks at different heights pace their exchanges with distinct rhythms. Equilibrium becomes a choreography across levels rather than a uniform stillness. The simple act of measuring a period becomes a craft. Astronomers select a line in a spectrum and watch it shift and broaden. The broadening comes partly from speed, partly from gravitational redshift. Models disentangle the two. The time series of brightness rises and falls in quasi-periodic fashion as clumps of plasma circle and shear apart. In each crest and trough, there is an imprint of the distance from the central mass. The habit of these patterns across days or weeks allows mass and spin to be estimated from afar. The act is not magician's work, it is bookkeeping of beats. Inside the mind, a thought experiment sets two clocks on different tours. One hovers at steady radius kept aloft by engines. The other makes a swift loop close to the limit, then returns. When the clocks reunite, the one that took the deeper turn will have recorded less time. The difference is not preference, it is geometry. World lines, like paths across hills, have lengths that cannot be faked. Gravity writes the metric, and the metric adjudicates the dispute without passion. The result is a memory in metal, a permanent testament that time flows along routes shaped by mass and motion. A quiet corollary arises for signals that carry information. Any bit encoded in light and sent upward from close to the edge arrives with its rate attenuated. Streams of bits that seem confident at emission become sparse at reception. This dilution explains why certain processes appear to freeze when watched from a distance. The freezing is an illusion made real by delay. The source is not halted, the path is extended, and the exchange is taxed by redshift. Recognizing this removes the need for drama and replaces it with patience. He concludes the meditation with a gentle confession. Time near a compact mass is both elastic and honest. Elastic because units stretch and shrink in response to curvature. Honest because every adjustment follows laws that permit predictions to be verified. The comfort lies in this duality. Moments become larger without becoming vague. Signals dim without losing their accounting. Clocks disagree and then reconcile through equations that never raise their voice. In the deepest well, the universe does not hurry anyone. It lets each observer keep a private rhythm and then offers a shared mathematics by which those rhythms can be compared. He listens to a soft machinery of light, where matter learns patience in a circle. A compact mass sits in darkness while gas gathers with a politeness that only gravity can teach. The result is a disk so thin that it looks like a whisper, yet its power rivals a galaxy when the inflow is generous. Every ring moves with a rule. Inside orbits are faster, outside orbits are slower. Friction between neighboring rings warms the gas and drains its angular momentum, letting it drift inward by microns, then meters, then thousands of kilometers, all without a single jolt. Heat escapes as radiation that spills across the spectrum. The color of that spill carries a memory of distance from the center, like tree rings that glow. Viscosity in ordinary liquids comes from molecular collisions. Here, the true agent is a field that hides in turbulence. Tiny magnetic threads are sheared by differential rotation. The threads tangle and amplify until they tie neighboring layers together. This magnetorotational engine converts orderly spin into internal motion and gentle heat. Nothing explodes. The disk behaves like a well-tuned loom that turns rotational energy into light. The pace is set by a parameter that looks small in equations, yet commands the fate of the flow. With only a hint of stickiness, the rings carry their heat outward and their mass inward, finding a steady state that lasts for years or centuries. The disk thins when cooling is efficient. Photons exit faster than gas falls, and the structure resembles a blade of light with a thickness that is a small fraction of its radius. In that regime, each annulus radiates like a mild blackbody with a temperature that rises toward the inside edge. The innermost stable circular orbit forms a border for true circular motion. Inside that radius, support fails and matter plunges with new speed. The change imprints itself on the spectrum, setting the maximum color temperature and defining how efficiently rest mass is turned into radiation. The conversion can exceed 10% for rapid spin, a quiet triumph for gravity's thrift. Close to the inner edge, iron atoms become narrators. Hard photons from a hot corona above the disk strike the surface and knock electrons from iron's shells. The atoms answer by releasing characteristic lines that are broadened, blue-shifted, and red-shifted by speed and gravity. The line becomes a curve with a long red wing that reveals just how near the gas has traveled to the central well. That wing is the signature of geometry. It draws a silhouette of the inner boundary more faithfully than any photograph. Spectrometers read this curve like archivists, retrieving mass and spin from the shape of a single stroke. Brightness refuses to be completely steady. Quasi-periodic oscillations rise as hums at preferred frequencies. These hums do not shout, they hint. Some follow the orbital clock near the inner edge. Others track the gentle nodding of the disk itself, a precession caused by the twist that rotation imparts to spacetime. Still, others resemble trapped waves that slosh within the disk, acoustic or corrugation modes that prefer select pitches. Together they form a suite of tones that map vibrations of curvature and flow. To listen is to measure. The score delivers masses, spins, and tilt angles without opening the dark interior. Between disk and object hovers a cloud of fast particles that shapes the light with a quiet hand. Soft photons from the cooler layers enter this coronal bath and are scattered to higher energies, climbing into the X-ray band after a few encounters. The result is a spectrum with a gentle rollover that betrays the temperature and depth of the cloud. Variability in the hot layer produces echoes as the disk reflects and reprocesses the hard light, creating delays measured in milliseconds to hours depending on scale. These lags serve as rulers for height and geometry. Light itself becomes a surveyor's tape. Not all flows are thin. When the supply is stingy, the gas fails to cool and swells into a puffy configuration that radiates little. Energy stays with the ions and rides inward rather than escaping as light. The radiative efficiency falls, the glow dims, the object eats quietly. At the other extreme, when supply overshoots a classical limit set by pressure of radiation, the disk thickens only modestly. Photons become trapped and are dragged inward with the flow, yet a substantial part of the power still finds its way out through winds or along funnels that form around the axis. The picture never becomes chaotic. The system chooses a self-regulated lane where forces balance without fuss. Instabilities can decorate these lanes with rhythms. When heating and cooling respond differently to temperature, rings can cycle between brighter and dimmer states on timescales set by the viscous drift. In some sources, the light curve beats like a living pulse, cresting and resting in a pattern that repeats for months. The cycles remind the watcher that a disk is not a rigid wheel but a responsive medium. Pressure waves race. Magnetic loops break and reform. Patches of higher density shear and spread. Each process has a time and a scale that collaborate to produce visible cadences. Polarization adds a final layer of calm information. Scattering in the flat disk aligns the electric field of light in a preferred direction. Rotation in curved space and passage through magnetized plasma rotate that direction by calculable amounts. Measurements of how that alignment changes with energy trace the altitude of the corona and the tilt of the plane with respect to the eye. Even here the message is modest. A few degrees of rotation write paragraphs about geometry. No storm is needed to provide these clues. A gentle swirl and a steady lamp suffice. Jets may launch from the inner regions when magnetic fields gather their tension along the axis. The connection between disk state and jet strength writes itself into radio and X-ray colors. When the spectrum is hard and the inner flow is thick and hot, collimated outflows often carry energy away in long, steady beams. When the spectrum softens and the thin disk reaches inward, the jets can fade or break into bursts. The duet of disk and jet never degenerates into chaos. It behaves like a tide chart where phases and amplitudes cycle with measured grace, their mutual feedback moderated by conserved quantities. Simulations now paint these scenes with pixels and field lines. Numerical experiments let virtual gas fall, heat, tangle, and radiate under equations that respect relativity. The pictures show hotspots that orbit and shear into crescents. They show shadows that waver as turbulence breathes. They show how returning radiation, bent by the well, can strike the disk again and add a faint embroidery to the light curve. None of this exceeds what instruments can test. The match between synthetic observations and real data grows tighter with each generation of code. The comfort lies in confirmation. Beauty in images does not substitute for truth. It meets it. Scale transforms the pace but not the language. Around stellar remnants, the inner orbits complete in milliseconds. Around giants at galactic centers, the same rings require minutes or hours. The tones slide accordingly, yet the sequence of phenomena stays loyal. Thin states, thick states, hums, echoes, lags, iron wings, and gentle flares all reappear with tempos set by mass. The invariance allows calibrations to carry across size, turning a single toolkit into a universal interpreter. That portability is soothing, because it suggests that the cosmos prefers reuse over novelty when a design works. Even in silence, the disk guides the eye. When plasma dims, the silhouette of the central darkness becomes clearer against the glow that remains. The edge of the shadow is shaped by where photons can linger and where they must break free. As the disk brightens, the border softens, yet it still anchors the scene. Painters would call it negative space. Physicists call it a photon capture region that changes subtly with spin and inclination. Observations taken over long campaigns watch the border breathe and tighten, always within the narrow range that equations predict. He sets these pieces together like instruments in an orchestra. The violin voice comes from thermal emission that peaks in soft energies. The cello voice comes from the iron line, slow and red with weight. The woodwinds speak in quasi-periodic tones that mark turning and nodding. The percussion belongs to flares from magnetic reconnection that crackle and then calm. The conductor is gravity's metric, which signals entries and exits without raising a baton. The music is not violent, it is exact. The visitor who learns to listen can hear mass and spin in the timbre alone. There is solace in this economy. Matter that could have scattered across interstellar distances finds a path to transform motion into light with a few universal steps. Viscosity shares, radiation cools, orbits adjust, fields align. The entire arrangement is a lesson in how complexity can produce steadiness without losing texture. The hum is not monotony. It is order with nuances. A ring may sing, but the song changes gradually with radius, and within that transition live the quiet facts that reveal what sits at the center. The darkness does not need to speak. The disk speaks for it in a voice that never strains. He steps across a border that makes no ripple and finds a geography with its own quiet grammar. Inside a non-rotating black hole, the symbols that mark radius and time trade duties. The coordinate named r, which outside behaved like distance from a center, becomes a measure that advances as surely as proper time. The coordinate that read like time takes on the role of a spatial direction. The exchange is not a trick of notation. It is a sober account of causal order. The interior is a corridor rather than a chamber, and all free paths move forward along r, the way all lives move forward along time. The corridor narrows, not because walls push in, but because geometry says that tomorrow lies at smaller r. The visitor who falls freely keeps a small laboratory tied to his motion. A frame of measuring rods and clocks accompanies the descent, aligned with the natural directions that a gyroscope prefers. Within this frame, the laws are ordinary. In the brief window before tides grow strong, Small experiments report the usual constants. Light still moves at its familiar speed relative to the local instruments. The equivalence principle preserves local calm even as global fate settles. That juxtaposition creates the feeling that the interior is both dramatic and uneventful. On scales that fit in a hand, quiet. On scales that encompass the corridor, inevitability. Tidal gravity is the lyric that begins softly. For giants at galactic centers, the curvature at the horizon is mild. A person crossing feels the same comfort as a diver slipping below a still surface. Deeper in, R shrinks and curvatures rise like a slow swell becoming a wave, lengths aligned toward the center stretch, lengths around the center squeeze. The pattern is set by the Riemann tensor and reads like a score for deformation. If the traveler carries a ring of test particles, he watches the circle become an ellipse, then a thin line, then an idea. Nothing tears by decree. Shapes change because space measures separations differently with each step inward. Inside this corridor, geodesics act like rails. Each time-like path is a line of least resistance through the geometry, and each line insists on the same destination. There are no side doors that lead back out. That is what it means for R to behave like time. To choose a different R would be to choose a different future, which cannot be done once the frame is fixed. The mind might search for a maneuver that saves it, some rocket burn or clever orbit. The metric answers with steady clarity. Burns can change how quickly R advances or how much turning occurs in the angular directions, but they cannot reverse the flow that R prescribes. The result is strangely soothing. Anxiety falls away when options end, and attention returns to measurement. Maps that served well outside must be traded for kinder ones. Coordinates that freeze the horizon produce artificial singularities that are only skin deep. Kruskal and Eddington-Finkelstein charts peel away the disguise and reveal a smooth passage into the interior. In these charts, the horizon is a slanted line, and the future that lies within is a region where the rails converge on the place R equals 0. The drawing is simple, almost childlike, a diamond of fate with a tip that marks the end of extendable time-like paths. The picture carries no alarm. It is a reminder that geometry can be kind to thought even when it is stern to bodies. Rotation complicates and enriches the corridor. For a spinning object, the ring of mass drags its neighborhood into a gentle twist, and the interior presents a second horizon, the Cauchy horizon, inside the first. Between them sits a region where rotation aids motion around the axis and leans light cones toward that flow. The mathematics allows, in principle, a passage through the ring singularity if one follows curves that avoid the central plane, yet nature hints at instability. Infalling radiation, however faint at first, is focused and amplified as it approaches the inner horizon. The blue shift becomes severe. Perturbations that would be harmless in calm environments become forces that reshape the interior story. What begins as a graceful staircase can crumple into a hallway of distorted mirrors. Even this warning arrives with restraint. It says only that the simple ideal must share the stage with the late consequences of every small disturbance the universe provides. The singular point of the non-rotating case is not a point in the ordinary sense. It is space-like, more akin to a moment than a place. The traveler does not aim at a location on the left or the right. He aims at a time that awaits all time-like paths once the horizon is crossed. That time comes quickly in proper seconds for small holes and more slowly for large ones, yet the order is the same. The space-like nature of the end means that no last message can be sent to neighbors who fall behind or ahead. All futures meet the same curtain. The curtain is not an explosion. It is a failure of the classical script continue. The volume behind the horizon presents an interesting paradox. If one chooses slices that cross the interior at later and later exterior times, the interior can contain regions of large spatial volume even while the outer silhouette remains unchanged. The corridor lengthens in those slicings, not contradicting the advance of R, but complementing it with a point of view that emphasizes how much space a single horizon can shelter. The image is that of a small mouth, leading to a great hall, a hall that grows in certain measures, while every time-like path inside still streamlines to an end. It is a mathematical fact that feels like a fable about hidden spaciousness. Signals inside obey an etiquette that keeps causality precise. Light can still race ahead of slower travelers along any local direction, yet it cannot outrun the conversion of R into time. A flash sent forward along the corridor arrives at neighbors who are also falling. No flash sent outward can reach the exterior world once the boundary is crossed. Information circulates among those who share the corridor and disappears from the universe outside. That is not an act of censorship. It is the structure of the cone of possibilities written into the metric. The cone tilts, and with it the paths tilt, and with the paths the conversations. Matter that falls does not arrive as a gentle fog in all stories. Streams may be clumpy, magnetic fields may thread the flow, and the interior can become a theatre where fields and fluids interact under intense curvature. Yet even in this complexity, there is a notable absence. There is no drumbeat of shocks at the horizon itself. Turbulence and waves belong to the dynamics of the infall, not to the crossing of the edge. Inside, the evolution may resemble the late stages of a complicated river course, eddies folding into larger currents, currents stretching into filaments. Each structure lives on borrowed time measured by R. The approach to the curtain gives every pattern a limit that does not depend on mood. One can imagine an explorer releasing a cloud of tiny clocks and mirrors, a constellation meant to map the interior by exchanging flashes. The data would assemble into a diagram of distances and times along world lines that rush inward together. The diagram would record the increase of tidal terms, the squeeze in transverse directions, the stretch lengthwise, and the acceleration of all separations towards zero in the final moments. The explorer would learn that geometry becomes the only author near the end. Materials can no longer resist, bonds break, particles follow curves written by the curvature that now dominates every local equation. Energy behaves with a particular directness inside. The stress energy that exists within any matter or field contributes to the growth of curvatures that are being measured. The link between energy density and geometry is no longer a gentle influence on strolls and orbits. It is the sovereign of motion. Inflow that carries even a small trickle of light from the outside universe is sharpened into a torrent near an inner horizon if rotation is present. That sharpening is not explosive in the cinematic sense. It is a focusing that grows without bound, a lens that tightens until the light it handles becomes its own sculptor of space. Some conjectures about cosmic modesty assert that the universe hides the more exotic possibilities with a veil of instability. Naked singularities without horizons are discouraged by arguments that amplify perturbations until a horizon forms or the candidate self-destructs. Inside a spinning corridor, the inner horizon may be replaced in practice by a weak but unavoidable singularity that protects predictability for anyone outside. The interior then retains its quiet authority for the majority of its length and reserves the turbulence for the final stretch where no message can be sent back anyway. The effect is a kind of cosmic courtesy that keeps the exterior world orderly. He looks at the equations that accompany this walk and notices how few ingredients are needed. A metric with a handful of parameters, geodesic equations that say, move straight by local lights, field equations that tie energy to curvature with one proportionality. Out of these, an interior arises that feels inevitable. There are no contrivances, no secret mechanisms. The silence is not emptiness. It is the sound of a story with very few nouns and verbs, all of them complete. The portrait closes with a moment of attention to scale. For a modest stellar remnant, the time between crossing and curtain is a fraction of a second. For a black hole that anchors a galaxy, the interval can admit a recitation, a set of experiments, perhaps a farewell. In both cases, the experience is defined less by horror than by clarity. Options diminish gracefully. Measurements remain honest. Frames carry their little laboratories until geometry asks them to stop. Even endings can be calm when cause and effect keep their promise. He contemplates a glow that begins without a lamp. A compact darkness sits under a cold sky, and still the arithmetic says it cannot stay perfectly quiet. The stage is space-time itself, gently curved, with a border that sorts futures. Quantum fields drape that stage like gauze, never truly still, always trembling with zero-point motion. In this setting, the notion of empty becomes relative. A detector that rides one path calls the field quiescent, while a detector that holds another path hears a faint hiss. From this difference, a temperature emerges that belongs not to matter but to the horizon. The story can be told in several dialects. One speaks of modes of a field that look like harmonics of a violin string. Far from the mass, the modes are labelled as particles by distant timekeepers. Near the border, the same field must be described with a different clock. The translation between dialects is not perfect. It mixes creation with annihilation, as if a change of language turned silence into a whisper. The result is a thermal spectrum measured at infinity, with a temperature fixed by the surface gravity, the gentle pull that light itself feels when it idles at the edge. Large masses have weaker surface gravity and therefore colder temperatures. Small masses have stronger surface gravity and glow more warmly. Another dialect distills the same truth into a picture of pairs that flicker at the boundary. In the restless vacuum, excitations arise together and normally fall back into cancellation. At a horizon, the flicker can be divided. One partner slides inward as if repaying a debt. The other escapes outward, promoted from virtual to real. The partner that falls carries negative energy relative to far observers, trimming the total mass. The partner that rises becomes a photon or another light particle that drifts away. The picture is a heuristic sketch, not a literal portrait, yet it captures the bookkeeping that the more exact language encodes in its transformation of modes. The spectrum of this glow is simple at its seed and nuanced after it meets the world. The seed is thermal, a plan of frequencies set only by temperature. On the journey outward, curvature acts like a filter. Some paths are harder to climb than others. The probability that a given energy clears the barrier is called a gray-body factor, and it reshapes the raw spectrum into what a distant ear will actually hear. Low-energy quanta find the climb most difficult and are partially turned back. High-energy quanta depart more freely. The final mix still carries the calm signature of a temperature, but with edges softened by the root. Particles of different spin feel the climb differently. Scalars wander out with one pattern of filtering. Photons carry polarization and follow another. Neutrinos participate if they are nearly massless. Gravitons, the ripples of geometry itself, emerge in principle as part of the choir, though their detection would require sensitivity beyond present craft. Charged or rotating objects complicate the mix further. Rotation allows superradiance, a process by which certain waves steal a portion of rotational energy and depart amplified. Charge attracts or repels excitations with matching sign and alters the balance. Even in these refinements, the rule remains gentle. The horizon responds to environment with quiet adjustments that keep energy and angular momentum conserved. Temperature dictates fate across long arcs of time. A compact object will emit more than it absorbs when the surrounding bath is colder than its own thermal glow. In a universe filled with a faint background left over from an early fireball, there is a mass scale that marks equality. Heavier than that, the object is colder than the bath and gains energy from it. Lighter than that, it is warmer than the bath and loses energy. The threshold sits far below stellar masses. Giants in galactic centers are colder than any known sea of photons. Their glow exists in principle but is buried under the rain of starlight and gas. Tiny relics, if the cosmos forged them, would warm as they shrank and eventually end in a brief, hot release of their last store. The timescales for the middle ground are longer than stories, longer than civilizations, larger even than many cosmic epochs. Evaporation is a promise kept in patience. Heat capacity carries a surprise that feels like a philosophical wink. Ordinary objects cool as they lose energy and warm as they gain it. Here the sign is flipped: lose energy and the temperature rises. Gain energy and the temperature falls. This inversion means that thermal balance is not like a bath and a stone coming to a shared warmth. It is a precarious poise. Any perturbation that reduces mass accelerates the loss, while any that increases mass deepens the chill. The curve of temperature as a function of mass slopes the opposite way from everyday experience. Stability belongs to the cold giants bathed in external glow, not to the small embers racing toward a final flare. He imagines placing a thermometer near the border and learns a caution. Local temperature is not the same as what a far receiver infers. A static observer who resists the pull and hovers close to the edge will measure a higher temperature because his clock runs slow relative to distant time. The redshift that dims and cools escaping quanta also means that local detectors feel a warmer bath. There is a consistency condition that keeps the second law safe in a gravitational field. When corrected for the differing tick rates, a smooth equilibrium can be defined. The horizon fits this scheme cleanly, as if it were designed to harmonize thermodynamics with geometry. No glow begins without a source of order to consume. Entropy provides the ledger. Assign to the horizon an entropy proportional to its area in natural units and a temperature proportional to its surface gravity. Then insist that the first law of thermodynamics holds. The result is a set of relations that allow one to treat the edge as if it were a system with heat content and mechanical work terms. These relations do not depend on any microscopic picture. They are statements about how large-scale quantities must trade with one another if consistency is to be preserved. The simplicity of these laws is soothing. They hum with the same cadence as the old laws for steam engines, transplanted into curved space. Questions nest softly within this calm. The glow looks thermal, which suggests a loss of detailed memory in the outgoing quanta. Yet the full evolution of a quantum system is supposed to be unitary, preserving perfect correlations. If the radiation is truly featureless, a ledger of information appears to be erased. There are proposed paths toward resolution that avoid loud rebellion. The exterior quanta could carry subtle correlations that become evident only across long sequences. The edge might act as a storage device, encoding history in structures that are non-local from the viewpoint of simple fields. The interior might feed correlations to the exterior in a way that leaves no contradictions for any single observer. Each avenue attempts to keep peace between temperature and memory without inviting a quarrel at the horizon itself. Trans-Planckian worries arrive and are answered with reserve. If a detected quantum at modest energy seems to have been born from a mode that was once bluer than any familiar scale when traced backward near the edge, does the effect depend on physics not yet known? The weight of analysis suggests robustness. The spectrum arises from features at scales much larger than the deepest wavelengths, and families of modified models still produce a nearly thermal output. The glow looks like an infrared truth, insensitive to the unknown details of what the fields do at impossible frequencies. He considers companions to this phenomenon in other settings. An observer who accelerates steadily in empty space measures a temperature in the vacuum that others call cold. A horizon can also belong to an expanding universe and carry a warmth associated with its own scale. The common thread is not material, but causal. Where signals can be permanently hidden behind a boundary, quantum fields conspire to dress that boundary with a temperature. The pattern hints at a unity between information, geometry, and thermodynamics. It does so without noise. Each example is a soft pronouncement that the vacuum is never merely nothing. Observability favors patience and cleverness. For the largest specimens, the glow is drowned by ambient light and by any trickle of gas that strays too close. For the smallest, the glow becomes bright only in the final instance, a time that may be rare or absent if such relics are uncommon. Indirect searches look for slight excesses of light in particular bands, for statistical hints in the backgrounds that fill the sky, or for transient flashes that could be the last sighs of ancient embers. The lack of a loud detection does not dim the principle. It underscores that the cosmos often hides its deepest rules behind veils of scale. The final image is gentle. A horizon that looks like a final wall turns out to breathe in quanta, out quanta, balancing on the hinge of temperature. The process respects every symmetry that counts and violates none of the quiet commandments of energy and cause. A dark geometry acquires a blush so faint that only the most faithful instruments or the most patient mathematics can register it. He hears that blush as a note held almost at the threshold of silence. It is the sound of nothing learning to glow by following the oldest law in physics. Warmth, it seems, is not a property reserved for fires and bodies. It can belong to a boundary in space, where future and past agree to exchange secrets at a measured rate. He considers a ledger that never permits erasure. Quantum theory keeps books with a perfection that borders on moral law. A closed system evolves by a unitary map, carrying a pure state to another pure state, without theft of detail. Phases may tangle, amplitudes may trade weight, yet the total information remains intact. Against this creed stands a quiet furnace that seems to wash stories clean. The radiation that drifts from a compact darkness looks thermal, indifferent to origins, soft as steam. If the glow is truly featureless and the source can fade entirely, what becomes of the specifics that once defined every atom that crossed the brink? The question is not loud. It is a folded note left on a desk, asking for an answer that does not wrinkle the page. Entanglement sets the tone. Whenever two parts of a quantum world interact, they can share correlations that exceed any classical pact. If one piece is hidden, the visible piece looks mixed, warm, anonymous. That anonymity is only a mask. The full pair retains purity. In the presence of a horizon, this habit becomes a puzzle. Early radiation leaves entangled with partners that have slipped inside. Later, radiation tries to do the same, but entanglement is loyal. A qubit cannot be fully married to two spouses at once. Past a certain hour, known as the page time, the demand that new light remain entangled with what fell in collides with the demand that it also knit to what has already escaped if the whole story is to be pure. The conflict is quiet and sharp. A curve helps to picture the stakes. At first, the entropy of the radiation rises as new quanta depart carrying little memory, just as hot coals steam away indistinct fragments. If unitarity holds, the curve must bend downward after the halfway mark, revealing that later quanta arrive with the precise correlations needed to cancel the anonymity of earlier ones. The descent is not a loud inversion, it is a counting. Each late photon carries a slight bias, a whisper of pattern that only becomes legible when pages are combined. For the curve to fall, the exterior field must be a subtle archivist, storing the library in cross-references rather than in any single spine. Scrambling offers a method for that archive. Inside a strongly interacting many-body system, information spreads. A simple perturbation dissolves into fine patterns that involve most degrees of freedom. Black holes appear to practice this art at a remarkable pace, re-expressing a small input across their variables so quickly that no subregion can display the original form. To a naive measurement, everything looks thermal. To a reader with complete access and the patience to combine long sequences, a message can in principle be reconstructed. A parable captures this. Toss a diary into the well. Wait long enough for the contents to be scrambled. Once the emission resumes in earnest, the outgoing stream begins to reveal, bit by reluctant bit, the text that seemed lost. The recovery requires exposure to the combined signal and clever decoding, not violence at the edge. A stricter thought experiment presses the promise. If a compact object scrambles quickly, then after a modest delay, it behaves almost like a mirror with memory. New messages thrown in can be recovered from later radiation with a waiting time that scales only with the scrambling rate and the size of the system. The claim does not say recovery is easy. It says recovery is possible in principle if physics respects unitarity and if the hidden dynamics spread information efficiently. The horizon then becomes a courteous boundary rather than a shredder, allowing the outside world to reclaim what it once surrendered, though only through a patience that outlives empires. Tension returns at the border. A smooth crossing for a freely falling traveler requires the field modes just inside and just outside to be entangled in a precise way. That entanglement supplies the calm vacuum at the edge. But if late radiation must be entangled with early radiation to drive the page curve downward, how can the same quanta also cement a perfect interior vacuum? One pair cannot anchor two bonds with full strength. The dilemma suggests a trilemma. Keep the smooth horizon, keep unitarity, and keep ordinary locality, and the three pull against one another. Some tales break the vacuum near the edge into a wall of energetic quanta, but that cure feels too dramatic for a boundary that is otherwise polite. Hints arrive from geometry dressed as information theory. The exterior region that includes both the distant detectors and the emitted radiation may have a larger entitlement than first guessed. If one asks which part of the full quantum state can be reconstructed from a given boundary domain, the answer depends on the shape of entanglement. Under certain conditions, the region of influence for the radiation can include an island that lies where intuition would place it off limits. Correlations then allow exterior readers to access interior data without sending messengers across the edge. A paradox softens. The ledger can balance if the bookkeeping domain is widened with care. Error correction offers a second hint by quiet analogy. In good codes, the logical content is spread across many physical bits so that local damage cannot erase it. Reconstructions can be made from different overlapping sets of carriers. The same logical note can be recovered from several partial views, each blind to the exact micro-details of the others. Holographic stories borrow this language to speak about how bulk events are encoded on screens with lower dimensional dynamics. The mapping protects meaning against noise and hides redundancy in a way that keeps locality approximate without allowing contradiction. The edge then acts less like a wall and more like a code space where different observers read complementary pages without producing copies that clash. Soft hair adds texture to the edge. Symmetries at infinity imply an infinite family of charges that track delicate memory in the passage of light-like disturbances. These charges are small and easily overlooked, yet they label configurations in a way that might seed a new count of microstates. Edge modes of fields contribute degrees of freedom, whose presence could explain why area measures entropy while the interior grows by other yardsticks. If such accounts are right, the border is not blank wallpaper. It is a ledger with fine print that standard thermodynamic eyes blur into a single number. Complexity becomes a third axis on which the riddle can rest. The total state of the system may remain pure, and the information may be present in the outside world after the bend in the curve, but the act of decoding could demand circuits whose depth grows faster than any practical resource. The interior could then be understood as a manifestation of complexity growth, a geometric shadow of computations that have not been completed by any feasible observer. In that view, no basic law is betrayed. The limit belongs to effort, not to principle. The calm at the horizon survives, because no actor can marshal the steps required to force a contradiction within a lifetime or a light year of hardware. Throughout, complementarity serves as etiquette. No observer is granted two incompatible transcripts. A traveler who falls keeps the right to experience a quiet crossing and cannot also carry to the outside a record that would expose a duplicate diary in the radiation. An astronomer who stays outside can, given inordinate patience, reconstruct correlations from the glow, but never meet the traveler to compare notes. The world refuses side-by-side experiments that would embarrass consistency. This is not evasive. It is the standard discipline of relativity applied to quantum narratives. He circles back to the mood of the ledger. Every serious path seeks to preserve the triad of calm horizons, unitary evolution, and respect for causal structure. Each introduces new furniture in the room, but the room remains dim and ordered. Islands expand what counts as outside without raising voices. Codes distribute meaning so that no small window can steal the whole view. Edge charges scribble marginalia. Scrambling hides messages in patterns that only long arithmetic can reveal. Complexity guards the door with a lock, whose key is possible but impractical. The note on the desk stays folded, yet its presence is answered by the arrangement of the space around it. The likely truth is gentle. Information does not die. It migrates into correlations so widely shared that only the most global of readers can recover it, and only after the passage of a great patience. The horizon remains soft to those who cross and opaque to those who hover. Entropy tallies the number of ways the edge can dress itself, without changing the few macroscopic numbers that describe its stance. Radiation learns to carry letters written in an alphabet that looks random to any short glance and meaningful only to a long gaze. The paradox dissolves not in drama but in bookkeeping. He closes the ledger with care. Somewhere in the future of a compact darkness, when the curve has changed its slope and the glow is old, a pattern will complete. No sparks will announce it. A sum will simply reach zero, and the archive will stand, disguised as ordinary warmth. If the cosmos has a temperament, it prefers resolution without spectacle. The calm that black holes teach applies even to their most severe question. The darkest places do not erase, they rearrange. He entertains a quiet suspicion that space itself keeps its memory on the edges. The clue arrives in a rule about counting. If energy and matter are sealed within a region, The number of distinct states that region can hold is limited not by how much volume it encloses, but by the area that surrounds it. The figure is not arbitrary. It equals the area measured in natural units that hide Newton's constant and the speed of light, the same combination that sets the warmth of a horizon. What looks like a simple inequality reorders intuition. Depth does not own the stories, the surface does. From that counting rule grows a principle. Every description of a gravitational world can, in some circumstances, be translated into a theory that lives one dimension lower, painted on a boundary without gravity. The picture is as calm as a reflection in still water. Events in the interior become patterns on the edge. Each pattern is sufficient to reconstruct the drama within, provided the rules of translation are obeyed. No light leaves a black region to carry news outward. Yet the field that dresses the exterior learns to encode the interior in correlations spread across the boundary. The night behaves like a hologram. A laboratory for this intuition presents a universe that curves inward like a bowl. Along the rim resides a field theory with no gravity, but with symmetry and discipline. Within the bowl, space-time breathes, according to general relativity, complete with waves, horizons, and collapse. The two descriptions speak different dialects, yet they narrate the same play. A black object, sitting quietly in the interior, corresponds to a warm state on the rim. Temperature on the boundary equals surface gravity inside. Vibrations of the boundary stress match the ringdown of the interior. Signals that never escape the well are reborn as subtle features in the static of the edge. The duality is not allegory. It is a dictionary. Entanglement turns into geometry in that dictionary. Select a patch of the rim and ask how deeply the patch can know the interior. The answer arrives as a surface that dips inward from the edge to enclose a slice of space. The surface is chosen by an extremal rule that balances area against quantum contributions. The area, divided by the same constant that measures horizon entropy, equals the entanglement entropy of the selected patch with its complement on the boundary. A fact about information becomes a shape. Change the patch and the surface repositions itself with the grace of a soap film. Where the film lies, the boundary can reconstruct. Beyond it, knowledge fades. The map is patient and exact. A network of simple tensors offers a toy model for this map. Arrange small nodes in layers that widen as they approach the boundary, each node passing compact summaries of its inputs to the next. The pattern resembles a tree whose canopy is the boundary theory, and whose trunk reaches into the bulk. Entanglement across the network controls the shape of the interior distances. Cut the web to separate two boundary regions, and the number of broken links approximates the area that a smooth surface would have spanned. The exercise is not meant to pretend, it trains the eye. Entanglement becomes the quiet mortar that holds space together. A black region framed by the bowl possesses a direct image on the rim. On the boundary, it looks like a thermal state, or a rapid conversation among many degrees of freedom, depending on context. The flow of energy into the interior translates to the spread of correlations outward. When the interior object settles after a disturbance, the boundary correlations relax with the same timescales as the ring-down frequencies measured by waves of gravity. A horizon that sequesters events does not defeat boundary knowledge. It reorganizes it into non-local cross-references that only wide eyes can read. Two copies of the boundary theory prepared in a particular joint-state mirror, a peculiar interior. The interior, in turn, contains two asymptotic regions joined by a bridge that cannot be crossed by travelers, but can expand and shrink according to the pace of correlation. The bridge is not a conduit for messages. It is a geometric echo of entanglement. Widen the correlations and the bridge lengthens. Let them weaken and it thins. The relation is gentle and exact in the dictionary. Geometry registers the tone of the bond without violating causality. Growth becomes a theme. Even while macroscopic features remain fixed, the distance through the interior between specified markers can increase with exterior time. On the boundary, a companion quantity rises as well. It is not entropy, which may already be near its ceiling, but computational complexity, account of the minimal steps needed to prepare the current state from a simple reference. The suggestion is that interior volume tracks the effort hidden in the boundary's tangled phases. No law is broken by this growth. It is a bookkeeping of structure that exceeds any quick decoding. Calm exteriors can hide long interior hallways of complexity. The edge respects covariant caution in its memories. The rule that limits how much entropy can thread a light-like sheet ensures that no paradox arises from packing too much story into a small curtain. The bound acts as a courteous guard. It allows saturation when a horizon forms and keeps all other arrangements below that mark. In this way, the surface remains a disciplined warehouse. Each square of area stores a fixed unit of possibility, never exceeding the capacity that gravity allows. Reconstruction follows a principle called the entanglement wedge. For any chosen set of boundary observers, there exists a bulk region that is theirs to decode. Signals that occur inside the wedge can, in principle, be recovered using only their data, while events outside require a larger coalition. This rule assigns ownership in a peaceful way. No single small group can claim the entire interior, yet coalitions can expand what they know simply by pooling their views. The arrangement honors causality and models how different communities of detectors might agree about a shared geometry without competing for exclusive truth. The gentle moral here is that locality is a service provided by entanglement. Nearby points in the bulk stay nearby because boundary correlations weave them together in the right pattern. Alter the pattern and distances change. In an extreme, remove enough entanglement and space itself can fragment. Hints of this behavior appear in simple models where diminishing correlations on the rim pinch off interior connections. Space is not a stage built once and for all. It is a tapestry whose threads are quantum correlations measured at the margins. A final comfort arises from the way this view speaks to fear of loss. If the surface truly counts and the dictionary truly translates, then no story that falls inward must be erased from the universe. It is re-expressed on the edge in a basis that looks scattered to small eyes and meaningful to large ones. The thermal glow that seems to forget is an average taken by impatient readers. Patient readers, given full access to the boundary and a very long calculator, can in principle assemble the correlations into a narrative. The price is effort and time, not violation of law. The horizon remains smooth, and the ledger remains balanced. He places a hand on the imagined boundary and listens. The sound is not loud. It is a coordinated rustle. Bits lean toward bits in patterns that shift with changes deep inside. A twitch of mass bends the network a little. A ripple of geometry refocuses correlations. Even silence in the bulk has a signature on the rim, a low resting state of entanglement that holds the interior together with the least fuss. The more closely he attends, the more the surface resembles an instrument that has learned every melody its companion can play. Edges, remember, not with letters carved in stone, but with harmonies that would take a lifetime to hear. He listens for music that does not ride air. Far from any storm, space itself can carry rhythm as a change of distance that passes through everything at once. Two compact gravities circle one another with patience that shortens imperceptibly at first, then quickly in the final dance. Each orbit leaks a little energy into the fabric around them. The fabric answers with waves whose amplitude is small enough to slip through planets without stirring a leaf. Yet the pattern is exact. Frequency rises with time, like a bird climbing a scale. Amplitude rises with frequency, like a choir growing confident. The whole progression is a chirp that ends not in a thud, but in a round tone as the final shape settles. The early motion resembles a waltz, with an almost constant tempo. Velocities are modest relative to light, separations are wide in units set by the total mass, and the signal builds slowly. In this regime, the waveform can be written as a series that corrects itself with higher powers of speed in a quiet ladder of refinements. Each rung adds a delicate twist to the phase, a nod to the influence of spin, a bow to the effect of eccentricity if any remains. The corrections are not decoration. They are the measure by which mass and spin can be weighed. A slightly different coefficient, a slightly different phase drift, and the hidden partners reveal their sizes. As the last few orbits approach, strong field effects take the stage. The path tightens. Speeds become a meaningful fraction of light. The frequency rises into a whistle. If the components of spin, the orbital plane can precess, tilting like a coin about to rest. That precession writes a slow modulation onto the faster chirp, an envelope that gives the angles away. If one spin is tilted with respect to the orbit, a gentle wobble appears. If both are aligned, the wobble is absent and the rise is more direct. The pattern carries nuance without clutter. A trained ear can hear the inclination of the spins in the way the pitch sways. Merging is brief and unambiguous. The two horizons meet and form one. Geometry that was two throats becomes a single throat that vibrates with a handful of preferred tones. These ring-down modes are damped and discrete. Their frequencies and lifetimes depend only on the remnant mass and spin. The first tone dominates, then the second, then the rest fade like ripples on a pond. Comparing these tones is a sober test of simplicity. If the measured notes agree with the numbers predicted by a remnant defined by two parameters, the portrait with minimal hair stands affirmed. The good news is that the match is close whenever the tones are heard with enough clarity. Polarizations carry the manner of the wave. In general relativity, the passing ripple stretches one axis while squeezing the perpendicular at the same moment, then reverses half a cycle later. The pattern is called plus or cross depending on the directions chosen. An interferometer that watches perpendicular arms measures the difference in length as beams of light compare round trips. When several instruments at different orientations listen together, the sky location can be triangulated and the polarization tested. The waves arrive with a speed that agrees with light to within a small fraction of a part in many quadrillions, a calm confirmation that geometry is the messenger. Distance can be measured without a candle. The strain amplitude depends on the intrinsic brightness of the dance, which is set by the masses and the dynamics, and on the distance that dilutes it. The shape of the chirp determines the intrinsic brightness. The observed amplitude then delivers the distance with no need to calibrate an intermediate rung. Such a source is a standard siren. If some independent clue yields the redshift, the pair gives a point on the expansion history of the universe. Stacked across many events, these points grow into a curve with errors that shrink under patient accumulation. The method is gentle and self-contained. Memory leaves a lasting kindness. After a wave train passes, free test masses can remain slightly more separated than before, as if space has taken a tiny step and chosen not to step back. This permanent offset is a second-order effect that rides on the energy carried by the wave. Detecting it requires long baselines and stable instruments, but its presence is a soft signature of the non-linear character of gravity itself. It says that waves talk to waves, leaving behind an imprint of their own journey. Not every binary meets in perfect circles. Some begin with eccentric paths that round off only late. Residual eccentricity shows up as power in harmonics, beyond twice the orbital frequency, a faint embroidery on the main thread. Eccentricity can hint at origin, because certain environments encourage close encounters that bind pairs with odd shapes and high initial speeds. A disk of gas around a giant can also leave marks on the song, slightly shifting phases or damping eccentricity with a schedule that depends on density and temperature. These environmental touches are modest, yet they turn the waveform into a stethoscope for surroundings. Recoil belongs to the aftermath. If the two partners radiate momentum asymmetrically, the remnant receives a push. The push can be a few kilometers per second, or, in extreme spin configurations, thousands. A large kick can lift the remnant from the heart of its host and send it on a slow excursion through the stellar field. The kick itself leaves a subtle mark on the late ringdown if the remnant moves relative to the detector, and over longer times it can shape the demographics of where quiet giants live. Even here, the process is polite. Momentum is conserved. The push is the exact price for a lopsided beam of waves. Instrumental listening is a craft of stillness. Seismic noise, thermal agitation, and quantum shot noise all try to bury the strain. Engineers quiet the ground, cool the optics, shape the laser light, and control the pressure of photons on mirrors. The remaining noise is modeled and subtracted, leaving a band where the sky can speak. With a library of predicted waveforms in hand, analysts perform matched filtering, sliding each template across the data to look for the faint correlation that betrays a signal. The technique is not magic, it is patience. A chirp that would be invisible to the eye appears as a clear ridge in the map of correlation versus time and frequency. Networks expand the ear. Multiple observatories listening together can reject local disturbances, refine sky positions, and compare polarizations. A triangle in space will soon join. tuned to slower rhythms set by orbits the size of solar systems. That ear will be sensitive to giants that take minutes to circle in their final arcs, to compact binaries of white dwarfs, crisscrossing like a mesh, and to extreme mass ratio inspirals, where a small companion orbits a supermassive host thousands of times before final embrace. Those sources write barcodes of frequency lines that drift slowly, each line carrying information about the shape of the spacetime it samples. The method turns orbits into surveys that map multipole moments with unmatched precision. A background hum may be present beneath individual songs. Countless distant pairs that never rise above the detection threshold contribute a stochastic field of ripples. Its spectrum depends on how often pairs form, how long they live, and what masses they prefer. Measuring this hum is like hearing city noise through a window at night. Peaks and valleys reveal the engines that run, even when no single car can be seen. Cross-correlating the outputs of two detectors can uncover this field because a real sky signal is shared while local noise is not. The statistic builds slowly and asks for years of data, an invitation to settle in. Tests of principle are built into every event. The phase evolution checks the strong field corrections predicted by the theory. The arrival time across a network checks the speed of the wave. The ring-down frequencies test the minimal portrait of the remnant. Any drift in frequency with distance would betray a mass for the graviton, which would alter long wavelength propagation. Any extra polarization would hint at fields that couple to geometry in unconventional ways. Each null result is not a void, it is a boundary that guides future thought. Lensing can act on these ripples too. A wave that passes near a galaxy can be delayed and magnified along multiple paths. For high frequencies, the effect resembles lensing of light, with images and time delays. For lower frequencies, wave optics can create interference patterns in the strain itself, gentle beats that carry the mass of the lens in their spacing. Observing such patterns would be a peaceful way to weigh structures that otherwise hide in dark matter. The wave remembers the detours it took without complaining. He pauses on the scale of the strain. The largest events that pass near Earth change separations by amounts far smaller than a proton over kilometers. The human eye cannot see such a change. Human skin cannot feel it. Yet light can register it. The smallness is not a barrier to calm appreciation. It is a reminder that the universe can whisper and still be heard if the listener prepares a quiet room. The signals travel unscattered across millions of light years, bearing pristine signatures of the gravities that made them. In a cosmos that often hides its deepest workings behind brightness and heat, these waves arrive as clean letters written on cold paper. The gentle conclusion is that darkness sings. The tones are not violent to the touch, they are rigorous to the mind. From them, masses, spins, orientations, and distances can be inferred with rules that reward attention. The repertoire includes chirps that end in steady hums, barcodes that slide slowly in time, and soft chords that never stop. Each adds to a portrait of compact gravities that form, meet, and settle with dignity. The ripples carry no dust, need no medium, and leave no wake beyond the memory they imprint. They are the calm confirmation that geometry has a voice, and that the night, if attended, will speak. He watches a circle of darkness grow out of daylight data. The telescope is not a single eye. It is a necklace of mountaintop dishes separated by oceans, trained to the same point in the sky, and disciplined by atomic clocks that disagree less than a heartbeat in a million years. Each dish gathers a faint whisper at millimeter wavelengths, a band where plasma turns almost transparent and light slips past crowded electrons without too much quarrel. The signals are recorded onto drives, flown to quiet rooms, and combined so that Earth itself becomes the lens. The method is very long baseline interferometry, a patient craft that measures not images but the harmonies of an image, the Fourier notes that can be woven back into a picture. The picture that results is not simply drawn, it is solved. Atmospheres flutter, receivers drift. The sky itself changes while the instruments stare. What survives these distractions are closure quantities, combinations of phases around triangles of dishes that cancel local mischief and keep the celestial truth. With these stable pieces, algorithms can search for the simplest map that explains the harmonies. Regularization avoids greed. Priors are gentle and geometric. Multiple teams, using different codes, assemble versions of the same scene and compare until consensus feels earned. The result is a ring of light with an oval of darkness inside, a silhouette that is not an object, but a gravitational possibility. The dark interior is called a shadow, though it is not cast by any solid surface. It is a cauldron of trajectories that cannot reach a distant eye. Photons that try to leave from within a certain ribbon of angles are trapped by curvature and led inward. Photons that skirt the ribbon and survive are bent into arcs that wrap around the well, meeting the observer from directions that make a ring. The brightest part of the ring is thicker on one side because plasma streams are moving there toward the observer at a significant fraction of light. Relativity raises the brightness on the approaching side and dims the receding half. The asymmetry is a quiet signature of motion and field. Distances and masses write themselves into the size of the hollow. The diameter is controlled by the scale of the photon orbit and the distances that deliver perspective. For a giant that rules a galaxy's heart, the ring spans tens of microarcseconds, as small on the sky as a donut on the moon. Yet when Earth becomes a lens, that size is enough. Baselines measured in continents provide the resolving power to touch that scale. When the circles on the Fourier plane are filled by nights of observation and multiple orientations of the Earth, the reconstruction tightens. The ring appears where it must, set by the gravity of the central mass and the angle of the view. One image arrives from a system where a jet pierces space like a steady needle. The jet tells the story of rotation and magnetic structure, but the ring tells the story of gravity. Its diameter agrees with predictions from simple metrics to within the uncertainty that weather and instrumentation impose. The thickness and brightness distribution depend on the behavior of the flow and on the electron population that radiates. Simulations that allow magnetic turbulence, heated electrons, and the dragging of frames can be compared to the data until a range of temperatures, field strengths, and viewing angles gathers support. The image is not a painting. It is a test of ideas about plasma under curved rules. Another image arrives from far closer to home, where the central mass is modest compared to giants yet still large enough to hold many suns in a calm grip. Here time variations complicate the work. Orbits near the inner edge complete in minutes rather than days, and the scene changes during a single night. Instead of a single static solution, analysts assemble snapshots and averages, letting the algorithms adapt to a trembling source. Interstellar scattering adds blur that must be unbraided using models of the screen that lies between the eye and the object. After this care, a ring again appears, with a diameter that fixes the mass when distance is known, or a distance when mass is known. Either way, the shadow becomes a measuring stick with no moving parts. Polarization maps deepen the portrait. Millimeter light carries the imprint of magnetic fields that thread the plasma just outside the hollow. When the polarization vectors are traced across the ring, they curl and twist in patterns that match the architecture of field lines wound by rotation. The sense of order says that turbulence does not defeat structure at the inner radius. Fields channel flow, resist chaos, and perhaps help launch the outflows that become jets far from the center. The polarization picture is quiet and exacting, a collection of short ticks that require both sensitivity and clean calibration. Together they write the presence of a magnetic engine onto the sky. The ring is not the photon ring in the strict sense described by textbooks. That ideal ring is a razor-thin contour where light completes precarious orbits before flying out after one or more circuits. Its surface brightness is low in practical images because the path length and redshift conspire to reduce its weight. What current arrays reveal is the emission ring, the bright boundary where glowing plasma near the innermost stable circular orbit appears, sharpened by lensing into a circle with finite thickness. Hints of substructure ride within this thickness, and future instruments may separate the narrow photon ring from the broader glow. For now, the visible ring remains a faithful proxy of the scale set by gravity. Imaging is checked by direct fits to harmonies. Before any map is drawn, the closure phases and amplitudes can be compared to those expected from a thin ring of given diameter, orientation, and thickness. The match often arrives even without the artistry of reconstruction. This redundancy calms fear of artifacts and lends weight to physical interpretations. The circle that the algorithms draw is not a conjured outline. It is a geometric answer demanded by the data. Variability provides another probe. Short flares brighten one quadrant, then drift, then fade. When those bright knots orbit near the inner edge, their motion imprints periodicity into the phases measured across triangles of baselines. The period betrays the radius of the orbit. The direction of drift reveals the sense of rotation and, sometimes, the tilt. If the flares recur with preferred spacing, they teach about hotspots, magnetic reconnection, and the time it takes for orbits to shear features into crescents. A patient campaign can turn these flickers into chronometers that count in minutes the physics of extreme gravity. Errors are treated like honored guests. Weather ripples phase, ground equipment ages. The line of sight through the atmosphere varies with elevation. To live with these truths, arrays distribute their stairs across many triangles and repeat measurements until outliers can be recognized without prejudice. Calibration is layered, with sky calibrators and engineering tones and cross-checks among stations. The images are accompanied by ensembles of possibilities, drawn from the same data using different assumptions. If all roads lead to rings of the same size within uncertainties, confidence is justified. The discipline is not theatrical, it is housekeeping. Hopes for the next decade are technical and serene. Add dishes to fill gaps in the Fourier plane. Place a receiver on a high-altitude aircraft or in orbit to lengthen baselines beyond the diameter of Earth. Widen bandwidths to gather more harmonies in less time. Synchronize stations more precisely. Correct for tropospheric water with faster metrology, and clock noise with sharper masers. Each improvement is quiet by itself and transformative in combination. Movies of the ring can then be drawn instead of single frames, revealing the dance of hot structures and the breathing of the silhouette with weather in the flow. Coordinated campaigns across the spectrum complete the scene. When a brightening happens in the millimeter band, eyes in X-rays, and infrared watch for companions, a flare seen in multiple colors carries a richer fingerprint of the electrons that radiate and the fields that guide them. The relative timing of peaks in different bands teaches about heights above the plane, cooling times, and transport. The ring thus becomes part of a symphony with parts that answer one another without crowding. The gentle triumph of these efforts is that a concept once drawn only in equations has learned to cast a measurable absence on the sky. The absence is not empty. It is a chart of light paths that do not reach us, an imprint made by the geometry of the deepest well that nature allows. The ring around it is the testimony of matter that circles and glows in an orderly way before surrendering. The harmony between predicted size and measured size, between simulated brightness patterns and observed maps, is a calm vindication. It says that gravity keeps its promises even where it is strongest, and that patient instruments can catch the outline of the invisible without drama. He opens a quiet ledger of rules that govern the darkest calm. A compact gravity looks like absence, yet it obeys a set of statements so disciplined that they read like a lullaby for extremes. Each rule assigns a simple quantity to the edge, ties it to a partner in mechanics, and lets the pair evolve with the tact of thermodynamics. The wonder is not that such laws exist, but that they are spare, universal, and kind. The first statement cares about uniformity. On any steady horizon, the surface gravity has a single value everywhere along the edge. No hotspots, no cold seams. The gentle pull that would keep a photon hovering at the border is constant, like the level of water in a lake that has settled after wind. This constancy is not an assumption. It follows from the geometry of stationary solutions that admit no news. The edge is a single temperature in the language of quantum fields, and a single acceleration in the language of classical motion. A second statement speaks of change. Add a little mass, a little spin, a little charge, and the quantities on the horizon respond with a balance that mirrors the first law of thermodynamics. A small increase in total energy equals a term proportional to the change in area, plus a term proportional to angular momentum change, weighted by rotational speed at the edge, plus a term proportional to charge change weighted by electric potential at the edge. The equation is neither noisy nor opaque. It is a soft ledger that distributes contributions without drama, keeping book as faithfully as any steam engine ever did. A third rule looks only forward. In classical processes, The area of a horizon does not shrink. Matter can fall in and make it larger. Waves can carry energy away and leave it unchanged. Shrinking is forbidden. This is the area theorem, a directional law that whispers about irreversibility. Folds in the edge may stretch or smooth, but when two dark regions meet, the combined area after settling down exceeds the sum they brought to the union. The law does not raise its voice. It tracks every exchange with an inequality that never flinches. The last statement of the classical quartet forbids perfect cold. No process carried out within the rules can bring the surface gravity to zero in a finite time. The unattainability of absolute chill echoes the third law of thermodynamics. Approaches can be made, limits can be neared, but the edge never becomes exactly slack under finite operations. The prohibition is gentle, a boundary drawn at infinity rather than a wall placed at arm's length. Attached to the area a proportionality that reads as entropy, and attached to the surface gravity a factor that reads as temperature, and the four rules become the four laws of black hole thermodynamics. The correspondences are more than analogy. They codify the fact that geometry carries a count of possibilities and a notion of heat, even in the absence of matter on the edge itself. The fit is vindicated by the faint glow that quantum fields permit, and by the way energy bookkeepers find every term in the ledgers balanced. Rotation threads these rules with grace. The edge turns, dragging space around with a measured angular velocity. The first law's rotational term reflects the work done by adding spin or extracting it. The area's refusal to shrink explains why one can tap rotational energy only up to a limit set by an irreducible mass that cannot be lowered by any classical means. Thoughtful trajectories through the whirling region outside the edge can return with more energy than they brought, but the cost appears elsewhere as a grow in area. The machine allows work while protecting its order. Charge adds a measured lyric. The potential at the edge partners with the change in charge to contribute to the first law. Once again, extraction is possible in principle, but the area enforces a floor on how far such efforts can go. The electric field organizes itself so that the edge honors the same accounting as a capacitor, with the curvature playing the role of a meticulous clerk. All adjustments occur without sparks or arcs at the rim. The drama lives in the book, not on the surface. A relation connects mass, spin, and area beyond small changes. It is a scaling identity that reads like an equation of state. From it, one can solve for the irreducible portion of the mass in terms of area and identify the recoverable part as the energy stored in rotation and charge. The existence of this clean split gives the mechanics a feeling of restraint. Nature permits extraction, but only through channels that preserve the quiet dignity of the edge's growth. The idea of entropy tied to area invites questions about origin. One answer treats the entropy as a Noether charge associated with the diffeomorphism symmetry of the gravitational action. In theories more general than Einstein's, the count changes accordingly, replacing area with a weighted integral of curvature on the edge. The effect is reassuring. The law keeps up with the theory. Whatever combination of geometric ingredients the dynamics respects, the entropy collects them as a surface density, as if the edge were a page that lists the active terms of the action in an elegant shorthand. Quantum corrections add small, steady notes. Logs of the area appear in refined counts of microstates in several approaches, adjusting the entropy by a term that grows slowly with the edge's size. The adjustment is gentle and universal in spirit, a reminder that finite size effects shade the cleanest thermodynamic relations without breaking them. A large horizon swallows the correction into insignificance. A tiny one hears it as a final grace note near the end of its life. The second law adapts as well. When a stream of radiation leaves carrying entropy, the area can shrink in quantum treatments. To protect the sense of direction, a generalized statement adds the entropy outside to the entropy of the edge, insisting that the sum is non-decreasing for complete processes. The world then keeps its promise that stories cannot unwrite themselves. The edge may give up a sliver of area, while the glow carries away a larger share of disorder, and the total curve remains upward. The correction is conceptually quiet, yet essential, a caesura that lets the melody stay true in the presence of quantum breath. An entire chemistry blooms if the constant that sets the large-scale curvature of space is treated as pressure. The first law gains a volume term, and the mass plays the role of enthalpy, the energy available once pressure work is accounted for. Phase diagrams appear in this new plane. Charged specimens in a confining background can pass through transitions that mimic the liquid-gas line of a familiar fluid, complete with a critical point and small, large phases. The analogies are not used to dramatize. They are used to organize, providing a calm map where state variables stroll along gentle curves rather than leap. Stability and heat capacity follow the same quiet logic. Objects isolated in empty space have negative heat capacity and cannot find stable balance with a thermal bath. Confined in a suitable geometry, they can possess positive heat capacity for a range of sizes and thus participate in equilibrium with radiation. A transition between a warm bath empty of edges and a warm bath filled with an edge can be as placid as frost forming on glass when the temperature slips below a threshold. These are not wild changes. They are ordered rearrangements chosen by free energy's least value. Viscous analogies give the edge a fluid's poise. In a membrane view, the horizon responds to tangles and tides as if it had a shear viscosity, a conductivity, and a finite resistivity. Ratios of these properties to entropy density attain simple limits that speak to universality. Perturb the edge slightly, and quasi-normal modes return it to rest with timescales set by surface gravity and radius, just as a liquid's ripples decay with rates set by density and viscosity. The resonance spectrum that rings down after a disturbance becomes both a thermal correlator for a boundary theory in certain dualities and a set of damped tones for the edge itself. 2 readings, 1 law. All of these rules are compact, yet they set a large table for measurement. Mass can be read from the size of the shadow and from the chirp of waves. Spin can be read from iron line wings, from jet structure, from ring-down frequencies, and from the brightness asymmetry of the ring. Area then follows, and with it, entropy. Changes in these quantities across a merger test the area law. The agreement of tones with the 2-parameter portrait of the remnant tests the calm adequacy of the first law's variables. Each test is a routine checkup rather than a trial by fire, and that is itself a comfort. The patient pass quietly. There is a final, modest insight that the laws encourage. When rules are this simple and this hard to evade, the universe invites respect for constraint. Extraction of energy, transport of charge, and exchange of heat take place within a geometry that treats every move with fairness. Nothing useful happens without a cost, and no cost can be hidden. The area does not lie. The surface gravity does not fluctuate on a whim. The rotation keeps its own tally, and the potential minds its units. It is a moral landscape for physics, calm and exact. He closes the ledger and finds that nothing in it has raised the pulse. The deepest wells in nature honor a quartet of statements that any student of heat could love, translated into the language of curvature. Edges act like thermostats. Areas act like diaries. Mass, spin, and charge play the roles of familiar state variables connected by identities that are both tight and forgiving. The night is governed, not by edict, but by balance. In that balance rests the most relaxing fact of all. Even at the brink of the unknown, order persists, and the laws speak softly. He enters rooms built for quiet. They hold vacuum chambers that mimic the hush of space and mirrors so still that a human breath would seem like weather. Lasers cross those rooms in long, pale corridors, measuring nothing and everything at once. When no signal is present, light cancels light. When space-time moves by less than the width of a proton, the pattern tilts and a fringe slides. The instruments do not seek spectacle. They seek the smallest change a patient eye can know. Out of that practice, a catalogue of dark dances appears, each entry a note with mass, spin, and distance inscribed in its phase. Light must be disciplined to hear geometry. Photons behave as individual messengers, arriving with a randomness that imposes a limit called shot noise. The remedy is to prepare light in a state with fewer fluctuations than usual. Squeezed light does this gently, shifting uncertainty away from the measured quadrature. Mirrors must be taught to hold their places to astonishing precision. Suspensions hang them like pendulums within pendulums, each stage filtering ground tremor away. Thermal motion would rattle the coating itself, so materials are chosen for their kindness to temperature. Even the pressure of light nudges the mirrors, and must be balanced. A small conversation between mass and beam that engineers settle with feedback that never raises its voice. Arrays of ears are better than one. When several distant interferometers listen together, local disturbances lose credibility and cosmic signals gain it. Triangulation narrows the patch of sky where a chirp was born. Polarization can be tested when the same wave arrives at different angles. Timing agrees to within milliseconds across continents, a confirmation that geometry carries news with the speed of light, as far as instruments can tell. The union of instruments makes the sky smaller and the evidence cleaner. Another ear is being prepared to float. In space, suspensions can be longer than mountains, and the low-frequency quivering of giants can be heard. A constellation of test masses exchanges laser beams across millions of kilometers. The separations are free of seismic noise and atmospheric flutter. Orbiting in a calm gravitational dance, the craft become an armature for rhythms with periods of minutes to hours. Supermassive pairs become audible. Small companions that circle them for years before meeting lay down a forest of spectral lines that migrate with the slow logic of relativistic orbits. The song of the quiet giants will arrive unblurred by Earth. Elsewhere, antennas made of dishes listen not to short bursts but to the slow push and pull that passes over decades. Pulsars act as cosmic clocks, beaming pulses with a steadiness that rivals atomic standards. A ripple that stretches the space between Earth and several such clocks leaves a correlated drift in their periods. Patterns in that drift reveal a background of long waves from countless heavy pairs that never rise to the pitch of a final chirp. The method requires patience measured in years, and the cooperation of telescopes spread across the planet. When the pattern emerges, it is not loud. It is the statistical consent of a dozen stars that something vast has moved. Light at shorter wavelengths supplies companion truths. X-ray spectrometers with fine energy resolution can measure broadened lines that carry the imprint of high speeds and redshift near the inner edge of a disk. Calorimeters count single photons and weigh them with care. Polarimeters trace the angle of electric fields, mapping magnetic structures that thread the flow. Infrared eyes catch the heat of flares that orbit and cool. Radio arrays map jets that hold their shape for light years, their knots pulsing with a schedule set at the engine. Each window opens on a different height above the plane and a different timescale. Together, they let observers stack slices into a gentle three-dimensional diary. Images at the smallest angles come from synchronized dishes spread across continents. Signals travel to recorders that keep nanosecond time. Later, in cooled rooms, the harmonies are combined. Closure phases survive weather and maintenance, and let maps be solved without guesswork about local delays. Polarization adds to the map, curling in arcs that follow fields. The ring of emission appears, and its size and brightness, asymmetry, pin mass and spin. This method is as social as it is technical. Stations, separated by oceans, must share nights, frequencies, and standards. The image is an agreement among strangers whose instruments speak the same language. Simulation is the other half of listening. Equations that govern gravity, electromagnetism, and plasma are solved on grids that follow curvature, with steps so small that gigaflops turn to teraflops, and then to more. The codes advance metrics and fields together, damping numerical errors the way a well-designed room damps echoes. In these digital laboratories, matter falls, tangles magnetic lines, heats, and cools by radiating. Photons are then traced backward from an imagined camera through the computed flow, gathering polarization, scattering, and absorption. The result is a synthetic sky that can be compared to the real one algorithm by algorithm, not impression by impression. Agreement builds confidence. Disagreement teaches what microphysics is missing. Waveforms are predicted in a similar way. Early in a dance, an expansion in small parameters gives a clean series for the phase. Close to the end, numerical relativity takes over, evolving two horizons through their meeting and the remnant through its ringdown. Surrogate models then compress these expensive calculations into fast functions that can be evaluated millions of times. Analysis teams match such families against data with Bayesian samplers, accumulating probabilities over parameters until a best region emerges. The output is a cloud in a space of masses and spins, a quiet shape that holds what the event allows us to know. No single number is declared without its uncertainty. The honesty is part of the craft. Tests hide inside these comparisons. A consistency check can be made that uses only early cycles to infer what the remnant should be, and only late tones to read what it is, then asks whether the two agree. Bounds on dispersion come from watching frequencies arrive in lockstep across a wide band. Additional polarizations would alter the response pattern across a network, and their absence narrows the possibilities for theories that try to add fields. When every check returns compatible, confidence grows that the minimal portrait with mass and spin suffices. If a deviation appears, its calm, repeated presence across events would be the first sign that gravity keeps a deeper notebook than anyone guessed. Laboratories on Earth study analog horizons with fluids and cold atoms. Water waves can be set against a current so that ripples cannot climb back above a point in the flume. Sound in a Bose gas can find a one-way line when flow exceeds a critical speed. These setups do not claim to reproduce a black hole. They reproduce the kinematics of a horizon and ask the quantum fields that live there how they behave. A faint thermal spectrum can be seen in some of these experiments, a soft hint that horizons and temperature are companions in many media. The point is not to settle cosmology on a tabletop. It is to give intuition a place to stand. The improvements in the coming years are practical and modest in tone. Longer arms on ground-based interferometers will lower noise at low frequencies. Better coatings will reduce thermal jitter. Higher laser power combined with refined squeezing will push quantum noise down without stirring mirrors dangerously. New sights will lengthen baselines and widen orientations, tightening sky maps and polarization tests. Arrays of radio dishes will add stations to fill holes in the plane of harmonies. Wider bandwidths will shorten the time needed to make a frame. Orbital elements will fly for space interferometry once control and metrology pass their rehearsals. Each small victory accumulates into clearer stories. Data handling grows in the same spirit. Pipelines are tuned on blind injections so that human expectation cannot steer conclusions. Open catalogs release events with posterior samples so that any reader can reanalyze. Cross-correlation between instruments at different bands and in different disciplines becomes routine, turning a solitary detection into a joint report. Standards for time and calibration are shared. Disagreements are tracked to their sources, whether a clock's drift or a cable's delay. The field grows not by drama, but by housekeeping. A final partner to listening is restraint. Selection effects bias any census. Loud events are not necessarily typical. Quiet ones often hide. Analysts fold detectability into their inferences, using hierarchical models to estimate the true distribution of masses and spins. They admit ignorance where the data are thin and let priors remain broad. With time, the uncertainty shrinks, not because anyone demands it, but because more instruments hear more sky for more days. The patience is the method. He looks around at the instruments and the codes and feels a theme that ties them. Each is a way to make room for small truths. Mirrors float, light is squeezed, atoms count, baselines stretch, networks coordinate, simulations advance, and analyses proceed with probabilities rather than proclamations. The result is a slow brightening of knowledge. Black holes do not become less mysterious. They become more intimate. The calm that belongs to them enters the laboratory and the computer alike. By treating noise kindly and laws with respect, the listeners and modelers redeem a promise that the night made long ago. The deepest wells can be studied without fuss. Measurement can coexist with awe. He imagines the cosmos taking a long breath. Night stretches in every direction, and yet it does not feel empty. Quiet shapes hold galaxies in their gentle grip, and the arithmetic that governs their edges settles into calm identities. A person who looks up might fear collapse or endings, but patience reveals something more restful. The centers where light bows its head are also places where measurement behaves its best. Rules simplify. Boundaries keep their quiet promises. Time adopts a humane pace and offers each observer the dignity of a personal clock. The lesson is not to resist the dark, but to learn the kinds of quiet it contains. A star begins with fire and ends with balance. Its ashes find an arrangement that wastes nothing and complains about nothing. Curvature replaces pressure as the moral that holds matter to its path. The night receives the remnant without ceremony, and the remnant returns the favor by tidying the environment. Gas that might have drifted for ages learns to circle neatly. Heat that might have hidden in confusion becomes an ordered glow. Waves that might have scattered arrive as concise phrases. From a distance, the whole performance looks like stillness. At close range, it is a garden of slow processes that almost never raise their voice. If fear lives anywhere in the picture, it lives in the imagination of abrupt endings. Yet the endings offered here are made of continuity. Motion flows into geometry rather than into fracture. A horizon behaves like a final page that closes itself without tearing the spine. Even the faint warmth that drifts into space from the edge speaks in the language of patience. Temperature takes its cue from surface gravity. Entropy counts in squares. Nothing is wasted. The book of cause and effect remains intact, the spine unbroken. The body responds to that tone. The mind, which often hunts for alarms, can sit with this and find none. Gravity is not a threat that demands vigilance. It is a discipline that invites trust. A poet might say the universe found an instrument that never squeals, only sustains. A physicist might say the field equations select solutions that minimize fuss. Either way, the sensation is similar. The night is knit together by curves that prefer economy, and the most economical curve of all is the one that asks light to choose inward paths beyond a certain border. It is not censure, it is completion. Completion does not preclude mystery. The ledger that forbids erasure without cost leaves room for subtlety. Correlations can hide in plain sight. Entanglement can store a library in notes that sound like noise to any hurried ear. Complexity can grow even when appearances hold steady. These are not threats to clarity. They are reserves of meaning that require long attention. To accept that is to accept that the universe values both simplicity and depth. A surface can carry the count. An interior can carry the journey. Each honors the other without conflict. A person might ask what comfort lives in a future where the deepest wells end with a faint glow and a sigh of final quanta. The comfort lies in scale. No loss arrives without a ledger that accounts for it elsewhere. No warmth escapes without informing the whole. The cosmos is a union of clocks that swap stories, and the stories change form rather than disappear. The field learns from the fall of matter. The night learns from the blush of edges. The far learns from the near. Even endings serve instruction. They tell that a quiet curve can teach more than a storm. The same person might wonder whether calm means indifference. It does not. Stillness can be the highest form of care because it avoids the distractions that breed confusion. A well-tuned instrument does not wobble. It holds its note and makes space for harmonies. These objects hold their note with devotion, and the harmonies that answer include rings of radiation, ripples of distance, arcs of polarization, and shadows that match the scale set by mass. Everything lines up. The sky becomes legible without being loud. Legibility breeds a soft courage. Curiosity can walk into this landscape without armor. There is no need to brace for surprise in the moral sense. Surprise exists in the intellectual sense, the sense that papers write down when they say a signal arrived in a range, expected only by careful theory. That kind of surprise is welcome. It is the surprise of a correct prediction kept by the world. It calms the heart by instructing it to expect order. It educates without scolding. It invites another question in the same patient tone. The final measure returns to light. Light is an honest witness. It turns red when it climbs and bright when it approaches. It maps rotation by leaning its polarization. It remembers the curvature in the rhythm of arrival. It admits delay without complaint. It dies the ring at a scale that circles the simplest mathematics. If one trusts light and the tools that treat it gently, the night yields its measures. Those measures then become stories for anyone willing to sit still. The stories make fear unnecessary, not because they tell of safety, but because they tell of consistency. Consistency is a cousin to kindness. If a world is consistent, it can be loved without the anxiety that comes from arbitrary change. The kindness here is not sentimental, it is structural. The field has no moods. Mass, spin, and charge enter, and a portrait exits with a clarity that helps minds rest. The same numbers measured in independent ways agree within patient margins. The margins shrivel with time. Everything that can be weighed twice, then thrice. and the readings will drift toward one another until disagreement loses its posture. He leaves the page with a sense that the night does not require heroics. It requires witnesses. To listen is enough. To measure with humility is enough. To let a simple curve be simple is enough. From such modesty, a surprising richness flows. The darkest regions are studious and courteous. They receive what the universe brings and answer with order. If peace is a physics term, it would be this: a place where geometry, information, and temperature live together without quarrel. The sky may continue for ages with that same demeanor. New instruments will sketch finer rings. New ears will hear quieter waves. New codes will paint sharper flows. Yet none of it will add drama to the edge that already rests in its principles. The refinements will only deepen the sensation that this corner of reality prefers balance. The gaze that learns this will carry the lesson back to daylight tasks. Work can be patient. Questions can be slow. Answers can be precise without becoming punishing. The model sits above the clouds and does not shout. It invites breath. He imagines closing his eyes in a field under a clear midnight. No declaration is needed. The earth spins. The galaxy moves. A gentle well at the center holds its form and its numbers. The peace that descends is not superstition. It is comprehension. A person can be small and still feel at home because the rules that write the night do not mock smallness. They ignore it in the best way, applying equally at every scale that instruments can reach. That equality is the secret comfort. The edge of a black horizon and the edge of a leaf are both served by geometry, by light, by time. To know that is to relax. He rests on a hillside where the town lights end and the meadow opens. Air tastes of pine and stone that have given up their heat. The sky is an old linen stretched smooth by evening. It does not ask for anything. It does not lean. It simply holds. Somewhere beyond that bowl, spaces curve into soft wells and teach stars to circle. Clocks glide. Photons learn patience. Heat counts in quiet squares. He follows a single distant gleam with the kind of attention that lets thoughts slow. The gleam is only a marker. The lesson is everywhere. Order does not need ceremony. The deep can be kind. Boundaries can govern without threat. The smallness of a human breath fits inside this logic without apology. If fear visits, it finds no purchase. The map is simple. Paths that enter certain rooms do not return, and yet even that finality is gentle. It preserves the ledger. It honors the balance. It turns complexity into clarity and leaves a residue of warmth so faint that only patience can feel it. He exhales with the night. The hillside, the town, the long dark architectures above, all share a rhythm that asks nothing but attention. In the quiet, a realization settles. Peace is not the absence of questions. Peace is the presence of rules that keep their voice low and their promises intact. He opens his eyes. The stars have not moved in any way he can see, and still everything is different. The difference is understanding. The deep is trustworthy. The dark steadies the bright. The universe, at its most extreme, is careful. That care is the most relaxing fact of all. End of script. Sweet dreams.